have heard about the Jam, and he is popularly known as Jam at various forums. He is closely associated with the CSPathshala team and associated with the CTiS conference from the inception. I welcome you, Jam. I welcome Abha Meghe, Director, Meghe Group of Schools, who is the driving force, a lighthouse motivator for the entire teaching fraternity of Meghe Group of Schools. Welcome you, ma'am. I too welcome Director Ajinkya Ambarkhane, sir, who is the Director for Meghe Group of Schools. I welcome Sonia, who is the strong support for the entire team of CSPathshala and Meghe Group of Schools too. Welcome, Sonia. And Sonia has supported us for all conferences. And of course, today she is with us in Nagpur. Thank you so much, Sonia. I welcome Kritika, who has been, the support for all our teachers, and today she is present with us. Kritika is a math educator, and she is from the Azim Premji University. I welcome Vinit Kapoor, who is the member of ACM Nagpur chapter, and who will be also the reviewer for us today, along with Kritika and Sonia. Welcome, Vinit. I also welcome the another all ACM chapter members of Nagpur, program committee members of CTiS 2023, my all principals, participants, and teachers. School of Scholars, which is the part of Meghe Group of Schools, has adopted CSPathshala curriculum in 2017 after the pilot implementation. From 2018, we have adopted it in a very structured manner by integrating it with mathematics and ICT. NEP 2020 also suggested to couple it with mathematics, which we have already done from 2018. 25,000 students of Meghe Group of Schools are learning the computational thinking from class 1 to class 8 till date. To adopt this, the thought was to develop a foundational skill of computational thinking, which we believe as foundational as reading, writing, and arithmetic. And it also developed a systematic approach to problem solving, a way of thinking, a way of reasoning about procedures, and understanding how procedure works. As I say, the program started with a structure, in a very structured way, the training program with the CSPathshala team and our resource center also. But the classroom practices, the platform that has been provided by CTiS conference, I say this is a platform for teachers to showcase their classroom practices. And the CTiS is a game changer in terms of the capacity building of teachers. It has played a very, very important role to boost the confidence of of our all teachers, and also given a platform to showcase their classroom practices. The journey has begun from the first CTiS conference. From our group, we were the 3 presenters there. But the regional conference that we had in 2020 was really a boost for all of us, where 35 plus abstracts were presented and 100 plus teachers of Meghe Group of Schools have attended the conference. And out of these, 11 were, 4 were presented in CTiS Pune. In 2 online conferences also, there was a very good response. But I would like to quote here the previous years, that is the CTiS 2022, where the 40 abstracts were submitted from our group and 11 were selected for the final presentation at ISER Pune. This year also, we have received the overwhelming response. We had the 36 submissions from our group, and to give the motivation to provide the platform to each one of them, the today in online regional conference, our 20 abstracts will be presented. So this all is possible with the management support and the support that is provided to each one of, provided by each one of you to us. So I welcome each one of you once again, and looking forward to a very fruitful presentations today. And my other colleagues will talk about that. We have tried to cover different themes here. And the CTiS also gives us insight about how do we really plan to reach out in a true sense to our students. That's what we are looking for, the outcome of this conference. So thank you very much. I would like to request now our director, Abha ma'am, to guide us. As I say, who is the, without her motivation, this venture was not at all possible. Over to ma'am Abha.
Thank you, Geeta. In this online conference, the second time happening in MGS, I welcome Professor Ramajanan, then Madam Sonia, Kritika, Vineet, and along with Vineet, today the Sarang is also present in this conference in the campus. With this, my team, with the under the Geeta's leadership, who is leading for the CSPathshala and all activities very effectively and very efficiently, I welcome the whole team of Meghe group of school here in this very hot morning, but we are at home, so everybody is in the AC, so it is not hot that way. So with this, I feel this is the proud moment for me to acknowledge the efforts of ACM along with the CSPathshala, because with the support of them, we could have achieved such a great success that 36 papers are going to be present today. It's a huge number, because every school and every subject is applying this computational thinking in their subject as well as in the classroom. Because computational thinking is an interrelated set of skill and practices for solving the complex problems, a way to learn the topic in many disciplines, and necessary for the fully participating in a computational world. So it is a necessity of this era to have this type of teaching and this type of activities in the classroom. As a foundation for coding and the computer science, computational thinking encourages students to reflect clearly on the problem which they want to solve and intentionally define the repeatable solution for it. It helps students to learn the design technology-based solution. Even in the real world, like arranging their room or arranging their bag or distributing the things in the school as well as in this home, everywhere they can apply this knowledge. And I really experiencing that the students are doing it well. The result of that, my students have developed many apps under the program of Go IT. So it's great pleasure to give this platform for my all students and share their experiences in this online conference. There are many benefits of computational thinking in education, which I feel, including increasing the critical, analytical thinking among the students, cultivating the CT skill, not only in the STEM, but STEAM, that is the art, including the other STEM subject. Improving the pedagogy and curriculum, it helps to the teacher to reach at the last child of the class. So from unplug activity to the algorithm, they are effectively making students capable to do the things with the help of CSPathshala. So I wholeheartedly, I would like to thank to ACM that they have developed such a great curriculum for the students, and it is a need of this world. Like systematic listening, counting and reasoning, modeling and organizational information, or following and diverse list of instruction, all these activities are very, very important while teaching any subject in the classroom. As we know, the India is the diverse country, or the diversity is the key of Indian culture. So this diversity is not only the cultural diversity. As the highly populated country, we have students of 40 in each class. And every child has their own learning style. With some students, as all teachers are here, so we know the different style of learning. Some are the what you can say, the audio learner, some are the visual learner, and some are the kinesthetic learner. So in this type of diverse classroom, handling a different need of a child and reaching to the every child, it's very, very difficult job. But I really appreciate the activities given in the CSPathshala, the unplugged activity, which I can say that really help to reach to the every child. Looking towards this year's theme of CTiS, the very important topic which you people are dealt, that is a CT for special students, which is very, very important, because otherwise all these subjects are made for only students, those who can do best. Or it is what you can say, it is thinking of the parent as well as the teachers कि ये activity तो सिर्फ अच्छे बच्चे ही कर सकते, those who are 80 plus, those who are 75 plus, they can only this activity. But I appreciate you have given this topic in this theme, and it helps to make even the last child of the classroom, or even the child who is having a learning disability, to do something best in his life, or apply this systematic approach of problem solving in their day-to-day life. We are not expecting that they can do something great in their life, but they are struggling with their day-to-day activity, and it will help them to manage their day-to-day forum and activities, which is really a great thought given by all the team member and the steering committee of CTiS 2023. In MGS, we are using all these activities in the classroom, and that's the result so many teachers are presenting today. Even the social studies teacher is presenting paper, even the English teacher is presenting a paper, computer teachers and math science, there is a common. I feel even the sports teacher can apply this knowledge in their curriculum. Geeta has to take care of these, and because in the sports also many things they have to plan a systematic. Even in football and all, they have a different type of movements. So if I feel there are also some analytical thinking, analogies are required. So even the sports teacher can apply this type of knowledge in their teaching on the ground. So next time I'm expecting कि sports का भी paper CTiS में रहेगा. Gita, you just take care of these, and definitely Dr. Ramajanan and Mr. Vineet will help, Vipul will help us in making my sports teacher best in applying these activities on the ground, which students will also enjoy. So with these, I feel today all 36 papers presenters, I would like to congratulate them for their efforts which they have taken in their, because school teaching is not an easy job. Every day they are busy with some or other activity, and so many things are happening in the school. So with that, taking time and writing paper, because it is possible, because they are using that technology in the classroom. So I congratulate all my team of teachers, those who are presenting today. With this, I would like to wish the best for the whole team of CTiS 2023 for their upcoming conference in Pune. And selected papers definitely will be presented there in the CTiS 2023. So with this is the great platform for you teachers. You take this opportunity to present yourself. This is a platform to sharing the ideas also, because the activity or the methodology used in social studies may be helpful to the English or mathematics. So share your ideas, share your thoughts, get implemented in your subject, and make every child possible to do their excellent in their future. Thank you for inviting me in this online platform. And once again, I would like to thank you to CTiS team, CSPathshala team, for making this event specially for MGS teachers. Thank you very much. All the best to all participants. Thank you.
Thank you so much, ma'am. Thank you very much. And as you mentioned, our English social science teachers, really, I think this CTiS has break the compartments in the school. And definitely next time, I mean, some of the art teachers have tried also this year. So next year, definitely will have some abstracts be written by our art teachers and post-scholastic teachers too. Thank you, ma'am. Thank you very much. Welcome to Vipul also. Hi, Vipul, and very, very good morning. Thank you for joining us. Next is, we are eagerly waiting to hear Jam. Jam needs no introduction. Everybody know Jam. So without wasting much of the time, over to Jam.
Thank you very much. It's a great pleasure to be part of the Meghe conference. It is, I mean, we have these computational thinking in schools, conferences. It's a great pleasure that apart from the national conference, we have these regional conferences. And Meghe certainly, I would say, is among the leaders in computational thinking in the country. While CSPathshala initiated the work, built the curriculum, and the great band of volunteers built the curriculum, this would not have become the movement that it is today without the extensive participation of teachers. And the Meghe group of schools has played a very important and influential role in making this happen. And therefore, it's additional pleasure for me to be with you. I think Ms. Abha Meghe has already given a very nice overview of computational thinking, its implementation in schools, And the fact that across curricular contexts or in all school activities, computational thinking can make a difference. Now, I think at the stage that we are in, I think it's again, wonderful to talk to teachers who have been involved in practice of these in the classrooms. This, as she mentioned, teaching is not easy, and it is there are a great deal of difficulties, especially when you bring in something new, and where you are creating new material, creating new educational resources, taking them to children, and looking at how reviewing what is going on. All this has been happening, and what is wonderful along with that is the writing culture. The writing culture that we see in these 36 papers from this group of schools. That is, I would say, if teaching is difficult, writing about teaching and pedagogy is 5 times more difficult. It's the reflective teacher who looks at her own practices, reflects on them, reviews them, thinks about them, is indispensable to education. And I think if you look at the great thinkers of education, Rabindranath Tagore, when he was writing on education, articulating his vision of Shantiniketan, says that if we can get a teacher who thinks, who talks, who is in harmony with nature, who looks at art and science with the same understanding, that is what education is about, right? And I think this idea that we reflect on our practices, share it with other teachers, talk about it, write about it, and discuss. I think this is wonderful. This is a culture that I hope will broaden and deepen in the years to come. And I'm glad in that sense that computational thinking is providing a context for such teacher writing and interaction. Now, we have been working on computational thinking. There are many ways it is moving forward. One way, like is being mentioned, is looking at computational thinking across curricular contexts. I would say that implementing this curriculum brings a whole lot of challenges. It is not only about lesson plans, scripts for how we do things, looking at them, activities, modules, but also assessment options. I think we need to look at how we do assessment of whether computational thinking is happening at all, and how much, along with the activities that we do, how much of learning is happening, in what sense. Now, I must say that these activities, games, puzzles are important in their own right, especially since we are talking about elementary education. The more we do of that, the more embodied learning that we do, the better for children in all contexts anyway. But along with that, if we had certain curricular objectives, how are they being met? Are there new behaviors that we see in children? Are we incorporating new beliefs? What are teachers' own beliefs in these practices? Now, these require discussion, thought, and I'm very happy that this is moving forward. And we want, remember, we want our schools to be schools of rational thinking. Right? The curriculum should emphasize intellectual skills, but also doing, where a lot of practical skills, where children do things. And thirdly, we also look for our schools to be those that where children's aspirations, children's minds, students' minds are met, and teachers and students engage in hopefully creating things of whatever form. Now, computational thinking is providing this opportunity for us to discuss and do these things. And my hope is that we come up with newer activities, newer ways of looking at computation, newer ways by which children identify patterns and express them. I think that getting children to express things in their own language and articulate in whatever form they have is perhaps the greatest strength of this program. And I hope we will continue in that direction. And another is this how we can interconnect our curricular areas. And I think this is another thing that is very important, that we are used to our own disciplinary compartments. If we can think across them and see, I mean, after all, today we are talking in in an era of something like ChatGPT, right? Where if we think of things like conversation, right? Writing essays, writing poems, would we even think of computers doing any such thing? But we are talking about it. Now, we have to look at these developments very critically, and we are hoping that our children grow up to be critical thinkers who are not merely consumers of computing platforms and software, but actually engage critically with that. Now, of course, we don't start talking about it. We don't start it. But it is when the thinking is embedded and understanding is built over a long time, that it is sustainable, that it is solid, and that leads to critical thinking. If at elementary stage, we are giving the kind of foundations, looking at the internals of computation, internalizing it into children's heads, our hope is that by the time they get to secondary school and secondary and tertiary education, they have the capability to understand what is going on and develop critical thinking. Not accept what comes, but use it wisely and critically to understand society. So it is that kind of citizenship education that we are building. And I'm very, very happy to be part of this grand exercise. And as I said, I think Meghe is certainly leading the country in this sense, but the NEP 2020 emphasizing computational thinking, there is a big buzz around it. All over the country, people want computational thinking curricula. And unfortunately, not with such detailed understanding or in-depth understanding, often thinking of it as coding exercises. So in this context, a group of schools with tremendous ability in not only implementation, but also in reflection and discussion is very welcome. And this platform, I hope, in the years to come, will become broader and deeper. Thank you very much. And thanks for giving me this opportunity.
Thank you. Thank you, Jam. Yeah, thank you, Jam. So I think this conference should be an insight, should throw light on deeper aspects of how do we really take it ahead and how really our students can be thinkers and what pedagogical changes are also required. I think this is the forum to discuss all the aspects. Thank you so much, Jam. Thank you very much. We have with us Vipul. Vipul is I think the leader who leads the CSPathshala, the whole curriculum and team. And Vipul is associated with us from the beginning. I think we have started with Vipul when he came to Nagpur. Thank you, Vipul, for joining us. And we are looking forward to hear you. Kindly few words from you.
Thank you so much, Geeta. Am I audible?
Yes, you are audible.
Thank you. Yeah, so it's always difficult to speak after Jam, right? I mean, he's covered everything. So, but one thing, I think what you said just now, I still remember the very first meeting I had with Ajinkya, and I think it's so much has happened since then. And I think I really must thank Abba. I think thanks to your leadership. I think as Jam said, I think you have been the pioneers of the CT movement in the country. We have learned so much from what the teachers have done. They have taken it beyond what we thought and what we expected them to do, right? I mean, we had the set of ideas with us, and it was so heartening to see your teachers transform those ideas and take them to a very different level altogether. And I think one thing I must say that I've learned in this journey, there are so many facets when you're interacting with students, right? So many facets of learning. I was telling Jam earlier, I was in one of the tribal parts in Odisha, and I visited one school, and this young man comes up to me and says, "Oh, why are you here?" And I told him, you guys are doing some wonderful work in computational thinking, and I'm here to meet you. So he looks at me and says, "Okay, but you would have seen a lot of people in the country do wonderful work. So why are you here to see us? What is it that you are seeing in us that you are here?" And I think there was a very, very nice question coming from a 10-year-old child asking me, why was I there? What is it that they were doing that I was appreciating, right? And I must say that CTiS provides us that platform to appreciate the work that children are doing, the work that you teachers are doing with the children, so that more and more people get to know about it. And I really again must thank you for all the work that you're putting in. I think it's good to see it move into different subjects, different areas, and I'm hoping and I'm looking forward to ideas in like you mentioned, sports, etc. So looking forward to that. Wishing all the teachers the very best, and thank you so much. And I'm glad to be part of this. Thank you.
Thank you, Vipul. Thank you so much. Now let's begin the presentations, and all the best to all participants. Okay, please keep your camera on when you'll be presenting. Share your screen. Okay, and then after your presentation, there may we'll have a good discussion and question answer session. Over to Pratiksha. Pratiksha ma'am will take the session ahead.
Yeah, thank you, Geeta ma'am. So coming to the presentations part, we received a total of 36 presentations for this regional CTiS, and out of which 20 teachers are going to present. There was a team of, obviously there was a team of reviewers who have reviewed this, and for the national conference, the papers will be selected from this presentations. So I wish all the teachers the very best. And now let us begin with the presentations. The presentations are under different themes. The first theme is CT and sustainability. And I hope the teachers are ready. The first presentation is from Sunita Maurya and Namrata Maurya. The theme, the topic is computational thinking, the first step towards innovation, adaptability and accessibility. All. So I request the teachers to kindly present.
Good morning, respected dignitaries, dear teachers. I am Namrata Maurya.
And I'm Sunita Maurya. We are here. It's a pleasure to present a paper in conference on theme CT and the sustainability. The subtopic is adaptability and accessibility in school, and we strongly believe that computational thinking is the first step towards the innovation. Computational thinking provides a structured and a logical approach to tackle everyday problems, enhancing our ability to identify solutions, increase efficiency, and optimize processes.
NCF encourages the use of computational thinking approaches to foster problem solving, logical reasoning, and analytical skills among students. It recognizes the importance of accessibility and inclusivity in education. NCF emphasizes the integration of computational thinking and sustainability into education. In the year 2017-18, we practiced CT in school in subjects like computers and mathematics. In 2019-21, we started to implement in other subjects like science and languages. In the year 2022, we applied CT beyond the scholastic areas to develop the problem-solving skills.
This time, our objective is to apply computational thinking beyond subject in problem-solving process. We worked in 3 steps. The step number 1 is the formulating the problem statement. Second is finding the solution. And the third, develop a model or a prototype which supports our solution. So in step number 1, where we have to search for a problem as our topic, we have chosen a topic, adaptability and accessibility for all in a school. So we have to find out the problem. Where is the problem? Where is an adaptability issue? So to understand what is the problem, to formulate a problem, we ask the student to collect the information from the students and the teachers. And they interviewed a number of students and teachers, and with the help of their own observations, they collected a set of responses. And using these responses, we have just classified all the responses into different headings, like some problems are related to classroom issues, some problems are related to the emotional issues, some problems are related to the study issues, some are related with the subjects, subject specific. So then we have just sorted out some of the common issues, and we have stated a problem. Yes, we'll pick up the problem which is related to the classroom, and we framed our own problem statement, that is to make the classroom more accessible for all learners. Now, once the problem statement was framed, we started working like, what is the solution? So in finding solution, again, we applied all the CT steps, like the data which we have collected previously, and the pattern recognition, then decomposition and abstraction. So while searching a problem, student identified some key reasons, like we picked up, there in classroom also, there are many problems. There is a distraction issue, there must be understanding issues and reflection issues. So the student identified, they just picked up few problems like distraction in the classroom, visibility issue, like because of uneven seating in a classroom, the students in the center or in the back may not be able to see the board, and audibility issues. So then we discussed more, then we focus, and then we narrow down our focus to 2 major issues, that is visibility and audibility. And after a lot of discussion, we come on realization that if all the students sat at the same level, it would create an obstacle for the sound and the light. So we started thinking, what is the solution for this? So the student discuss, they research, and they come up with a solution which involves the redesigning of a desk and the benches by incorporating adjustable screws and the plastic blocks supports for the height, which supports the height adjustment. As you see here, 3 different layers, like we have thought, 3 different levels: 0 level, which has no adjustment below it, and then the first level and the second level. So this way we can able to create a stepwise arrangement, and a student with at a different level can able to see the board, as well as they can able to hear, and teacher can able to manage the last benches with this kind of seating arrangement in a classroom. So as you see,
now while doing this project,
many challenges
while doing this project, we faced some challenges. The first was that to motivate the students, making them understand that computational thinking is not restricted to subjects, and then they can find a solution of any problem by applying computational thinking approach. Time management and coordination with the students was also a challenge which we faced during doing this project.
Now, let us talk about the impact. We proposed an innovative ideas by taking into an account the expenses involved in the making of changes and the modification required for both existing as well as a new system. While doing this activity, definitely the student worked on a different the 21st century skills. They also designed a new model, a new adjustable furniture, and they considered the strength of a furniture, comfortability of a student, and its utility in a multiple ways. They also have suggested a new design of adjustable podium, because when they have designed new furniture, so they also consider a podium, like, which is a very common, we are using everywhere, and the smaller kids, standard 1 student to standard 10, everybody is using a common podium, and it is really difficult for a smaller kids to use such a big podium. So they have applied and they have designed for adjustable podium also. So while doing this all activity, definitely we have learned that empathy is one of a very important skill, life skill. When if we work with empathy, we can give a better innovative solutions.
So here we conclude, computational thinking plays a crucial role in problem identification, systematic problem solving, and creating sustainable solutions. Pattern recognition and abstraction were utilized to address similar problems. The project aimed to make the school adaptable and accessible for all by using computational thinking. Thus, CT plays a very important role in problem identification and problem solving. Thank you.
Thank you so much.
Yeah, thank you very much, Namrata and Sunil. Any questions? So if there are any questions, you can just put it in the chat and we will discuss. Okay, so move forward. So coming to the next presentation, the theme CT for students with special needs. And the first presenter under this theme is Sunita Bhatia ma'am and Sangeeta Patil. The topic is approach of CT skills for students with special needs. I request Sunita and Sangeeta ma'am to kindly present. Any issues, Sunita ma'am? Is Sunita Bhatia and Sangeeta ma'am present here? Since Sunita Bhatia and these are not present, let's move to the next presentation. The next presentation is of Nalini Bhajibuje from School of Scholars, Beltarodi.
Yes,
the
ma'am.
topic is use of CT in helping visual impairment.
Yes, ma'am.
Please make one of the devices mute.
Hello, very good morning, ma'am.
Good morning.
Ma'am, actually it is showing Namrata Zarudkar name in my screen, but it's my screen, Nalini Bajpuje.
Okay, you can start with the
Yes, ma'am.
presentation. Yeah.
Is my screen visible, ma'am?
Yeah, it's visible,
Okay.
but you need to put it in presentation mode.
Yes, ma'am.
And Namrata ma'am, please start.
Good morning, one and all present here, all dignitaries. My name is Mrs. Nalini Bajpuje from SOS Belperodi, going to present use of computational thinking in helping visual impairment. Computational thinking is always gives a thought process involved in formulating problems, so their solutions can be represented as computational steps and algorithm. So in this paper, I want to highlight that our students of standard 8 found the problem with specially needy people and made the model Third Eye in Atal Lab by following the computational thinking skills. And we are very glad to achieve the recognition for the same during the Atal Mega Event competition. So in this paper, we use computational thinking skills like identification of the problem, brainstorming to decompose the problem, recognizing pattern of problem, designing thinking, and analysis. So for identification of the problem, to study about the problems of visually impaired people, students of Standard 8 visited the blind school under the community outreach program. And as per their observations, students understood the issues and difficulties faced by the blind children or people. Then they tried to decompose the problem. They found that there are many equipments to help visually impaired people. But if any obstacles is there at eye level, so these people cannot identify. So to help them, students gave a different thoughts to design the model by using the technology. Like they had thought to make sticks or cap or having sensors in the goggle to help the visually impaired people. So this gives abstraction and evolution, which change whole way of thinking about the resolution of the given problem. Then students made the prototype to design the model of Third Eye, which will be helpful for the visually impaired people to find out the obstacles at eye level. While making this model, students faced many challenges. After identifying the problem, when students made different prototypes to make some kits for visually impaired, it was already available. While making the model of Third Eye, students faced difficulty in adjusting the range of eye level. As the model is electronic based, they faced some connectivity issues. Sometimes sensor was not working properly. So like this, they faced the challenges. Then also they made, after finding the problems and everything. They made the model of third eye. And the impact, making prototype is physical computing. Without computational thinking, it would not be possible. So it helped to identify the community issues and enhance problem solving ability among the students. It increases the awareness about social or community problems. Computational thinking skill engage the students in experiential learning. Students acquired the knowledge of computational thinking while working on physical computing. Thank you.
Yeah. Presentation. Any questions? Teachers, you are free to ask the questions to the presenters. Yeah, ma'am, can you please stop sharing?
Yes.
Yeah. So moving to the next presentation. The next theme is CT in maths education. And we have received many abstracts under this theme. Let's call the first presenter now. She's Swati Madhav Ranade from School of Scholars, Atre Layout, and the topic is variation in counting combinations in CT activities and its impact on standard 3 students. Over to Swati.
Yes, ma'am. Ma'am, is my screen visible?
It's visible.
Yes. Good morning, all. I'm Mrs. Swati Ranade. I thank the organizers CTiS for selecting my abstract and giving me this opportunity for presenting my views in front of you. I also thank all my mentors for giving their valuable guidance in making my presentation. Let me take you through the same. The theme which I took for CT is impact of CT activities on students' learning. And the title of my topic is variation in counting combination in CT activities and its impact on standard 3 students. The topic which I chose was counting combinations. The students learn the concept of counting, concept of combinations from a very early age. They see and experience different types of combinations in their daily life related to colors, sizes, shapes, clothes, food, and numbers as well that they see around them. Taking a thread from the same concept, combinations in everyday life and the ways to count them was introduced. At first, simple combinations using only 2 colors, blue and white, were used for a flower and a pot and the pot. The strategy used was one variable was kept constant and the other variable was changing. The big task of counting all the combinations was broken down into simple tasks by this strategy. In this way, decomposition was introduced. Once the task was decomposed, that is broken down into known simple tasks, then a simple algorithm of freezing one variable and changing the other was used for counting all the combinations. Now the degree of difficulty was increased by adding one more color. This time the students used the same strategy and for counting and listed out 9 combinations. The students could explore methods for counting and systematic listing of possible outcomes, in this case combinations, in various situations. Now the variation part. One of the most popular tiffin items in school days is parathas. Most of the students bring parathas in their tiffin along with some sides like chutney or sauce. I took this near and dear friend of the students to introduce the method of counting combination in students. I asked the students to count all the possible combinations using 3 different types of parathas with 3 distinct colors. I used palak paratha green color, aloo paratha white color, and beetroot paratha pink color. They had to pair them with 3 types of sides, that is green chutney, tomato sauce, and curd, with the condition that one combination could have only 1 paratha and 1 side. The students could make 9 combinations using 3 parathas and 3 sides. Then I increased the number of sides to 5 and included coconut chutney and pickle as well, and asked the students to count the combinations now. They came up with 15 combinations this time. They could recognize the pattern to figure out the answer. Number of parathas multiplied by number of sides was equal to the number of possible combinations. Then I modified the condition that the paratha and the sides could not be of the same color. That is, the palak paratha could not go with green chutney. Then they figured out that now the number of combinations were reduced to 6, as 1 side was eliminated from each paratha. This is the picture which the children have drawn. Now the challenges that I faced. While counting these combinations, the students needed some concrete objects in front of them in order to count the combinations physically. It was also very difficult for them to ask to bring in their tiffins all these 3 types of parathas along with their sides, and that too on the same day. To solve this problem, I asked the students to draw the picture of all the parathas and sides. This enabled them to visualize the objects and then count the combinations. While counting the combinations, they use the same strategy of keeping one variable constant and changing the other. We can clearly see in the picture that the students have drawn the arrows from each paratha to all the sides. They have kept the variable of paratha constant and changed the sides while counting. Next was the impact. The students learned the strategy for counting combinations. The strategy is universally applicable to make combinations in different situations. Using the daily life combination of paratha and sides, which the students brought daily in their tiffin, I was able to relate the theory in real life application. This gave an insight to the students that what they have learned in their books or in the classrooms has its real life application and is not just a fancy theoretical concept. I could also extend the application of this knowledge to other topics like money and measurement. In the topic money, the students had to use combination of coins and notes to get the desired amount. In case of the topic of measurement, the students had to use different combinations of weights to measure the weight of a particular object. Like for measuring 1.5 kgs, they had to use 1 kg and 500 gram weight. Now the learning outcome, the students could learn a new concept of counting combination through known simple tasks. Then they understood the concept and importance of the pillars of computational thinking, that is decomposition, pattern recognition, algorithm, and looping. Systematic counting, listing, and reasoning activities ensured that nothing was left behind and that counting was foolproof. Also, the students learned methodically to count combinations without the fear of elimination. The student understood the real life application of counting combinations in almost all daily life activities, including planning food menu, deciding which clothes to wear, color combinations, etc., and found the topic very much relatable to their daily life. With this, I would like to conclude my presentation with the quote by John Dewey: "The real process of education should be the process of learning to think through application of real life problems." Thank you.
Yeah, thank you, Swati ma'am.
Ma'am, should I stop sharing?
Yeah. Yeah. Yeah, the presentation was quite good. We love the combination, even our daily life menus like paratha and all. Thank you for that. Now let us move to the next presentation. The next presenter is Mrs. Bhavna Borekar, and the topic is CT integration in mathematics. Over to Bhavna. Bhavna ma'am, you are on mute.
Hello, ma'am. Pratiksha, ma'am. Hello.
Yeah.
Hello.
Presentation.
Hello, ma'am. Pratiksha, ma'am.
Yeah, Bhavna, you are audible.
Yes, ma'am. Pratiksha, ma'am, please share the PPTs for me.
Yeah, I'm sharing.
Yes, ma'am.
Is it visible?
Yes, ma'am. Yes, hello, everyone. Myself, Bhavna Borekar. I'm working in School of Scholars at Nagpur, and my title is CT in Mathematics. And my topic is conversion of decimal numbers to binary numbers. I have used, next slide, ma'am. I have used flash.cards activity-based method and magic finger method to convert the decimal numbers to binary numbers. Yes, ma'am. Next slide, please. Yes, in this slide, I explained the flash.cards activity-based method. Now, the steps taken in this method are: first step, make sure to arrange the cards to correct order as shown in picture. Second, breaking down given decimal number as the addition of dots on the cards. Keep rest of the cards down. Next, if the cards has dot, represent it with 1 so that it can be counted for decimal value calculations. Otherwise, represented it with 0. Next, after solving some examples, students were able to generalize the pattern of arrangement of cards by multiplying previous number of dots by 2. Students were also able to find the steps to convert decimal numbers to binary numbers and were able to solve various examples correctly. Ma'am, please share next slide. Let's make it easier with the example. Now, as shown in picture 1, each successive place is 2 times of the previous one. At this stage, the teacher asks and motivates students to think that what do you think will come after 16? A teacher takes one example for it, that is, if we have to make the number 6 in binary, we keep the cards like shown in the picture number 2. When you see the back of the card, it will be 0. When you see the cards with dots, it will be 1. Hence, by using these cards, 6 can be represented in binary system as 00110. Next slide, please, ma'am. Next activity is magical binary fingers activity-based method. The steps are: show the students binary fingers and make them observe the pattern. Instruct the students to write all the numbers from 1 to 16 on their right palm. The teacher explained to students how to count the numbers on the right palm and let them find out how many numbers they can count on their right palm. The teacher asked the student, the teacher explained to student how to count numbers on their right palm and let them find out how many numbers they can count on their right palm. The teacher asked the student to generalize the same concept for their left hand and asked them how many numbers they could calculate using both hands. They come up to the answer 1023. So, next slide, please, ma'am. They can write down any number in the binary system by using these magic hands also. Next, magic zero at the last. Here, student compare two situations when we put the zero at the last of decimal number and at the last of the binary number. What is happening? The students compare the situation, find out the difference, and put their logic over here. That is, the student compare same number in decimal and binary number system. They found that the numbers were represented differently and they share the logic behind this difference. The decimal, when a zero is added to the right side of a number, it is multiplied by 10. This is because the base of the decimal number system is 10, and in binary, when 0 is added to the right side of a number, it is multiplied by 2. This is because the base of binary number system is 2. So, students conclude this result by observing various examples taken by the teacher as shown in above. That is, when we put the 0 after 111, it becomes 1110 in decimal number system, and it is represented as 111 multiplied by 10. And in binary number system, 1110 is equal to 14, which can be written as 7 into 2. Teacher wrote 4-5 examples on the board and let the student think over it and come to the conclusion. Next slide, please, ma'am. Some students were confused about the sequential order of the cards. Some students were confused about whether they should write numbers with their thumb or a little fingers. They were also confused about the sequential order of the card. So the action plan taken by the teacher is that the teacher took hands-on activity daily for 15 days for practice. The teacher repeatedly used hands-on activity to remind the students of the lesson. Teacher says, loudly says, starts from, students respond, the thumb of my right hand, and at the same time, the students holds up their hand, palm facing towards their face. Like this, they are written down all the numbers on their palm, and they loudly said that the thumb of my right hand, and they are starting writing down the numbers from this thumb. Some students who made mistakes were given personal attention. Now next slide, ma'am. Impact. Students learn decomposition, pattern recognition, and abstraction from both activities, and they enthusiastically tried different examples. Many students enjoyed the conversion without pen and paper, preferring to visualize with their fingers. Some students express their interest in discovering new number systems with different bases and building more compact machines than computers. Students were able to develop a systematic approach to computational thinking for problem solving. Thank you, ma'am. Yes, ma'am. Thank you.
Yeah, thank you, Bhavana ma'am, for the wonderful presentation. I think children must have enjoyed the binary system which you have taught, right?
Yes, ma'am. They enjoyed very much.
Moving to the next presentation. Sorry, the next presenter is Mrs. Kishori Shimpi and Mamata Verulkar from School of Scholars, Beltarodi. And the topic is integration education, systematic review. Over to Kishori.
Am I audible?
Yeah, you are audible.
Screen is visible now, ma'am.
Yeah, screen is also visible.
Okay. Good morning, everyone. Myself Kishori Shimpi and my friend Mamta Verulkar. We are from School of Scholars, Beltarodi, Nagpur. We are presenting the topic integration of computational thinking in mathematics. So these are in our school, CSPathshala is integrated with mathematics and ICT curriculum from standard 1 to standard 8. We have adopted the approach of CT in our regular math curriculum. We have included puzzles, riddles, which revolves around the different mathematical concepts and computational thinking skills. These CT skills develop observation skills, critical thinking, creative thinking, visualization, and problem solving skill in students. Student enjoy such activities with fun and entertaining. Now, from standard 1 to 8, we have included CSPathshala curriculum and everything in their curriculum. But what happens sometimes in higher grades also, we need these skills to simplify the problem. Just like standard 10th, we are taking one topic, arithmetic progression. How to simplify the sum by using CTiS skill. We have introduced the CT skill like decomposition, abstraction, pattern recognition, algorithmic thinking to solve difficult questions.
Yes. Concept of nth term of AP and sum of n terms of AP was discussed with students. Problem solving on the same was done by students. And so to give more practice, some complex problems also were discussed with students. Out of that, one of the tasks given to students was the sum of first 5 terms of an AP and sum of first 7 terms of an AP is 167. If sum of first 10 terms of AP is 235, find the sum of first 20 terms. If the difference between sum of n terms of AP and n minus 1 terms of AP denotes nth term here. Now this problem, when we have given this task to students, started doing problems, but most of the students, they felt some difficulty in this. They felt because the problem is little complex, we told students to apply the CT skills in this. Next slide. The students applied decomposition. Decomposition invites learners to break down complex problem into smaller and simpler problems. So here students break down this problem in smaller tasks, and students took first step as the sum of first 5 terms. That is, we are applying a formula here actually, S5 is 5 by 2 in bracket 2a plus 5 minus 1 into d. Then they have broken this in smaller tasks. Students took the second step as, next slide, they have finded S7, that is 7 in bracket a plus 3d. Then they took sum of S5 and S7. So they solved sum also, and then students have broken that in fourth step and fifth step also, as they have to find sum of 20 terms. They find it first term and common difference, that is D, and then they find it S20, that is sum of 20 terms. Prior knowledge enabled learners to break down the problem into parts, and the class discussion appeared to have reinforced learners' understanding of decomposition. So students were able to solve the problem with the help of decomposition. Next.
Now, how pattern used here, pattern recognition, how used to solve these such kind of problems. The learners were asked to identify the aspect of computational thinking that could be used to solve this problem. These challenges was presented to the learner to afford them opportunities to integrate aspect of computational thinking in mathematical learning. They justified their choice that given problem involved identification of number pattern. Pattern recognition guides learner to make connection between the similar problem and the previous experience. Just like here, we have to find out the sum of first 5 terms and first 7 terms. So they have used the formula of SN. And in SN formula, they have put value of N as 5, then N as 7, and then N as 20. So they found the value of S5, S7, and S20, which follows a particular pattern, and it helps them to solve the sum in stepwise, but along with the pattern also. So they recognized the correct pattern and calculated the correct solution. So S5 and S5 plus S7 is 167. They put the above values by using the formula of SN. Then they got pair of linear equations by solving that in terms of A and D. Then they solve that pair of linear equations in A and D and got the solution as A equal to 1 and D equal to 5. Abstraction. Abstraction invites the learner to identify the important information while ignoring unrelated or irrelevant details. Sometimes, or many of times, in case study questions or in objective questions, what happens? Some information is not related to the sum, or they just included to confuse the students. So by this CT skill, they can avoid the unrelated or irrelevant details, and they can focus on the important things and solve stepwise. So here, if we see the example, the first sentence is the sum of first 5 terms of an AP, and the sum of first 7 terms of an AP is 167. So S5 plus S7 is 167. Then sum of first 10 terms of AP is 20 terms of AP is 235. Find the sum of, sorry, S10 is 235, and then find S20. But the last sentence which is given, if the difference between sum of n terms of AP and n minus 1 term of AP denotes n term, it is not actually required, because it is obvious statement. We know Sn minus 1 gives us the an value. That's why it is not required. So this can help using the abstraction to the student. So S5, S7 are not consecutive terms. Sn minus 1 is, this information is extra information provided here.
Algorithms involve the design simple steps to solve problems. And as we have seen, students applied decomposition, they applied pattern recognition. In decomposition, they broke the problem in simpler tasks, and stepwise they solved problem. Then they recognized the pattern, then they applied all the steps, and so that it is nothing but algorithmic thinking is involved here. Above practice demonstrated that the integration of computational thinking activities in mathematics learning promises to be effective, means through which learners' understanding of mathematics content can be enhanced. Now, some challenges faced here, that is difficulty in transferring knowledge. that is the problem from student side, then making connections with prior knowledge and incomplete understanding of the language of math. That is the major problem of students, that if they are not understanding the language, they are not able to solve the problem. So early exposure is important to pave way to computational thinking, to make students understood that the integration of computational thinking is applicable in every aspect of life. That is also one of the challenge we faced. And the impact. CT skills like decomposition, algorithmic thinking, abstraction, then generalization are nothing but 4 pillars of CT developed through playway method while solving difficult problems. The implementation of these activities enhance and concretize the above, which can be applied in daily life. It was a great learning experience for students as well as teachers. Above practice demonstrated that the integration of computational thinking activities in mathematics learning promises to be an effective means which learners' understanding of mathematics content can be enhanced. Thank you.
Any queries or any questions?
Thank you, Mamata ma'am, and thank you,
Thank you.
Thank you.
Ishori ma'am, for the presentation. Next, we have a presentation from Prachiti Dharmadhikari, Senior Secondary. Over to Prachiti ma'am.
Thank you, Pratiksha ma'am.
You're on mute, Prachiti.
Yes. Am I audible now?
Yeah, you're audible.
Yes. So good morning to all the dignitaries and all my colleague teachers present over here for this 5th conference on computational thinking in schools regional conference. Directly, let us move to the activity which we have conducted for senior secondary. So actually, the activity that I have conducted is for class 12 students, and 9 students are involved in this activity, and the topic determinants were chosen to conduct the activity. Like activity conduction means how can we apply the computational thinking skills in solving the HOTS, that is the higher order thinking skill type of problems from determinants by integrating CT skills in it. So the approach that is adopted over here is the simple to complex. So how it was started? Actually, when I was explaining the topic was going on, I came to one of the question wherein I found that students are finding it difficult to solve a problem because they were not able to identify that which property should be applied here and how can they were going by a very lengthy method. So the question, firstly, I posed the question in front of them and I allowed them to solve it on their own. And then later on, I decided that this question we can go ahead with the CT integration, which will help out students to solve this similar type of questions very easily within fraction of seconds. So what was the question type? The question type is like we have to take a determinant of order 3 by 3 involving same 3 elements whose sum is 0, such that the elements occur in the cyclic order in the next row and no element is repeated in any row or column. So when I asked how did I start the activity here? So I divided the students in the group of 3 three students in three groups. And I just wrote 3 to 4 simple determinant examples based on the condition, like what was the condition that I have stated just now. And I asked students to identify that what kind of a pattern is followed in all these determinants. So for this, we have I allowed them to identify the pattern, and then I asked the students to comprehend the condition given in the problem or in their own words. And this is how I started with the pattern recognition. So first of all, pattern recognition was followed. So this is one of the determinant question which follows the given condition in the problem. Like we have to take 3 elements in the determinants. So what is the condition? That all of the 3 elements should be different, but the sum of all these 3 elements must be 0. And then how we have to place them in the 3 by 3 determinant order. So here we can follow the Sudoku type, like pre-knowledge. In Sudoku, how do we place the numbers or any objects? So there is some specific order that you have to follow. So the same systematic approach is followed in framing the determinant question. Like the students have to take, suppose 1 and 2. These are the first 2 elements the students have chosen. Now the condition is that the sum of 3 elements must be 0. So if they are taking 1 and 2 as the first 2 elements, the third element has to be -3. Then only the sum of all 3 elements will be 0. Okay. And once they have selected, they can place them in any order in the first row. And then after that, they have to follow the systematic arrangement to complete the determinant question. Like in the first place, we have taken 1, then 2, and the next is -3. Now this 2 goes in the first position in the row 1, then -3 and 1, then again start with -3, 1 and 2. So this order they have to follow, and the determinant question gets ready. So once the students understand the pattern of the determinant in the question, and they have applied some sort of Sudoku knowledge in framing the determinant of 3 by 3, now let us proceed to the next part. So this was the pattern recognition. The students were divided into the 3 groups. So I told them that you share your observations, what kind of pattern you have observed. So in the group A, students observed that sum of all elements in each row and column is 0. Then the students of group C, they shared that the same 3 elements are arranged there, and the same group C students stated that no element is repeated in any row or any column. Okay, so this was their observation. Now teacher has to pose a question, because now the question is ready, pattern recognition is done, and we have framed a question of determinant which we have to solve. Okay, now this was a simple question which we started with. As I stated earlier, that the approach that is adopted in this is a simple to complex approach. So simple means what? Numbers are the very simple questions to deal with for the first time. So that's why I started with the numbers at the first time. And now once the determinant question is ready, the teacher has to pose a question, because now we have to proceed for the problem solving. So for problem solving, we need to understand what kind of algorithm that we are going to follow to solve this kind of a question. So the question posed is, can we make all the elements in the first row or in the first column 0 by using any determinant property, and how? So now students have already learned the determinant properties of transformation of rows and columns, so they understand it, and quickly, because they are able to figure out that how can we make all the elements in the first row and column 0. Already all the elements in the first row, if they see that the elements are not repeated, so if they add all the elements in the first column, okay, or in the first row, then all of them are going to be 0. So what kind of the operation we can have over here is R1 changes to R1 plus R2 plus R3. So now these horizontal rows are R1, R2 and R3. So R1 changes to R1 plus R2 plus R3. So R1 is changing here, right? So R1 here in the first element, this element is 1. So if this changes to R1 plus R2 plus R3, like 1 plus 2 minus 3. So this is going to be 0 in the first element. Again, over here also, in the second column also, this is going to be the first, the element will be 0. Similarly, here also minus 3 plus 1 plus 2 is going to be 0. So what do we observe? That all the elements in the first row we can make 0 by using this operation R1. R1 changes to R1 plus R2 plus R3. Or we can also make all the elements in the first column 0 by having the operation C1 changes to C1 plus C2 plus C3. So if we solve it with the rows or columns, we may get it all the elements as 0. Okay, so we solved it with the rows, and as we get all the elements in the row 1 as 0, 0, 0, so clearly, okay, all the operations in the determinant will be multiplied with 0, and finally the answer is going to be 0 of the determinant. So it was very pleasant experience for me as well to find out the problem, identify the problem, and make it take it in the class in a way that students understand it easily. So when I explained, we handled 2-3 questions of the based on the numbers, and later on I asked them that now let us move on to a little complex type of a question in which we want all the elements that will involve the variables. Okay, so instead of numbers, now let us deal with the variables. So I gave them 1 or 2 elements like b minus c. This is one of the example which is given in the textbook. So I took it later on, but firstly I told them that you try to frame the question which involves the variable. So likewise here, these are the questions. Firstly, students framed the simple questions related to the numbers, involving the numbers as the elements, and very quickly they were able to do it. They took little more time to understand the complex type of a question, wherein they have to involve variables. So here you can see that a plus b and a minus b are the 2 elements they have selected. And once they select the 2 elements, then after that they are able to select the third element. So this was also the systematic approach. So I told them, like, you can have decide any 2 elements very first, and then you think of the third element. So this is how the students themselves, they came out with this conclusion that this is how we can proceed and take decide the 3 elements. And once they get the 3 elements for the determinant, they have to arrange them in the way which was stated. As the students are able to frame the questions on their own, they have understood the pattern of the question. So now they have also understood the algorithm. The similar algorithm will be followed in all these type of questions, and they will be finally reaching to the answer as 0. So this was one of the wonderful experience of conducting CT.
Sorry to interrupt you, ma'am.
Yes.
Please follow the time limit.
Yes, ma'am. Closing. Yeah. Okay, so these are the CT skills involved, which in the activity, pattern recognition, knowledge of Sudoku, algorithm, and problem solving. These are the challenges faced. Making students of senior secondary familiar with Sudoku, because students of senior secondary are usually involved in their own curriculum work. So it didn't take much time. It was very simple. With the one presentation, I was able to do it. Then getting the problems framed from the students and keeping students on the track of CT skills while they frame the questions. These were some of the challenges faced, and through their participation only, I was able to overcome these challenges. This was the impact that I observed from all the 3 groups, what I told them to frame the questions. So this was the way they were able to frame the questions. And this is the comparative impact that I want to share with all of you. So without city integration, firstly, it was explained. I just posed the question in front of them. So without interlinking it with computational thinking, so around 50% of the students look confused and scared of these type of questions. And also they struggled a lot to crack the questions with ease. And after integrating city skills in the type of a question, the same type of question was taken with systematic approach and exactly 100% outcome was achieved. And I think that these type of questions, if we take with city skill, it helps students in solving similar kind of questions in fraction of seconds in competitive exams. So thank you all of you. Here I would like to conclude.
Without form admission नहीं होता ना.
Yes, thank you, ma'am. May I stop presenting?
Now next we have, ma'am, can you please stop sharing?
Yes, ma'am.
Yeah, we are altering the top theme now. Let's call Mrs. Brushali Borkar, ma'am, under the theme CT in Science Education. Her topic is developing CT skills through projects in science.
Yes,
over to Brushali, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you very much for allowing me to present now.
You're welcome, ma'am. Please start sharing.
Yes, ma'am. So, good morning. Ma'am, my screen is visible.
Yeah, it's visible.
Yes. Good morning, Honorable Abha ma'am, Geeta ma'am, Jam sir, and the other dignitaries. So I wish a very good morning to all of you. My name is Brushali Borkar, and I'm presenting my and the topic of the project is prepare a list of famous food items eaten in why the particular dish is famous in a particular month or a season or in a particular festival. Create a balanced diet thalis, one for Maharashtra and one for Odisha with different food items and justify it as a balanced diet. So this was the project, and this project was given to the class 6 students as a subject enrichment activity. This was an individual project. Step by step, students were supposed to complete this project, including city skills. And these are some of the city skills which were included in this project, that is data collection, data analysis, listing and reasoning, algorithm design, and abstract. So this project was decomposed in some chunks. So the first part of this project was prepare a list of famous food items eaten in different states of India. So here, as per the instructions, students collected the data from the internet, books, and interacted with their parents. So here they use the skills, that is data collection. Then in the next step,
Ma'am, sorry to interrupt you. Have you shared the presentation?
Ma'am, it is not. I have shared, ma'am. 1 minute, ma'am. Is it not visible, ma'am?
Yeah, we are able to see.
Thank you, ma'am. So in the first part, they have collected the data, and in the second part, they have sorted the different food items and famous dishes of Maharashtra and Odisha, and they made the separate list of both. So here they applied the city skill, that is data analysis. Then the third part of the project is why the particular dish is famous in particular month or a season or in a particular festival. So to find out the solution of this problem, student applied the city skill, that is listing and reasoning. So here they investigate the reasons for variations in eating habits in different states of India. And in the next part of this project, they have to create a balanced diet thali, one for Maharashtra and one for Odisha with different food items. So here they applied the algorithm designing skill to create a balanced diet thali for Maharashtra and Odisha. With that, they have listed different nutrients present in it with their nutritional value, as well as students have mentioned the benefits of Maharashtrian diet and the diet of Odisha. And the last part of this project was the justification. So here they use abstraction to write the justification. They remove all the unwanted data collected and concentrate on the information that is relevant and important to write the justification. So in this way, they have completed their project using the computational thinking skills. So these are some of the challenges, that is time constraint. Time management is the main challenge. So it may require additional time and effort from both students and teachers. Then there may be the lack of understanding about how computational thinking can enhance scientific inquiry and other skills. So raising awareness and providing appropriate guidance is essential. The next challenge is integration into existing curriculum is also the challenge, because science curriculum is already packed with the content, project, and many activities. So to integrate computational thinking in science project may require careful planning, coordination, continuous support from the educators, then policymakers, institution. Providing teachers training can also be the solution to overcome these challenges. But it leaves a very positive impact on the learning process if we integrate the computational thinking skills. So this project was completed using city skills, which allow them to gain advanced knowledge with their discipline, which in turn raises their confidence, critical thinking skills, and problem solving skills. So here I want to conclude that these skills empower students to approach scientific challenges in a systematic and creative manner, uh, and preparing them for the demands of the digital age. So thank you, ma'am. Thank you very much.
Yeah, thank you, Brushali, ma'am, for the wonderful presentations. I think, yeah, you can stop sharing. The children must have enjoyed the CT skills through projects.
Yes, ma'am.
Next, we move to the presentations from CT integration in mathematics only. So next we have Puzzle with Numbers by Rima Kale and Nupur Phate from School of Scholars, Hudkeshwar, Nagpur. Is Rima Kale or Nupur Phate present?
No, Pratiksha, I can't find them.
Okay, so let's move to the next one. Archana Shetty ma'am and Mamta Kore ma'am. Are they present?
Yes, I'm present.
Yeah, so
Archana ma'am is not present for some reason, so I'll be presenting.
Okay, so next we have CT integration in maths lab activity by Mamata Kore ma'am.
Yes.
Yeah, over to you, ma'am. Thank you.
Thank you, ma'am. Good morning to all dignitaries and my colleagues present here. I am Mrs. Mamta Kore, presenting the topic City Integration in Math Lab Activities in the 5th conference of Computational Thinking in Schools.
Any difficulty, ma'am?
No, ma'am, I'm not able to see the screen. Shall I present?
Have you started presenting?
No.
Okay, you want me to share your presentation?
I'm not able to share the presentation, so please share now.
Okay, just a minute. Sabita ma'am, can you please share the presentation? Next presenters are Prakash Umap and Satish Burawar. I request them to be ready with the presentation.
Hello.
Hello.
Pratiksha ma'am.
Yes. Hello. My voice is audible, madam? Hello.
Yeah, you are audible. Yeah, you are audible.
Voice is audible, madam?
Yeah, you are audible.
PPT is visible? Yes. Hello. 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 Yes, PPT is visible or not?
Yes, sir, it is visible.
Yeah, your presentation is visible.
Yes. Myself.
You can start with the presentation.
I am alone, madam. Satish sir is not there. Alone I am presenting. Can I start? Yes.
Yes, yes, you can start.
Good morning, all dignitaries and dear colleagues, my teachers. Titles of this computational thinking is making arithmetic progression easy by using the computational thinkings. Here, in class 10th, it was observed that students used to commit the mistakes in question of arithmetic while finding the number of terms. Nth term, they were also confused finding the difference between the successive term when the terms are descending order. To overcome this problem, for finding a problem of for solving arithmetic progression question, we divided our instruction in the different steps as abstraction, pattern recognition, algorithm, methods, and by step method. This paper speaks about the integrating computational thinking skill in math curriculum of grade 10th. In math teaching learning easy in the word problem, we generally ask in the as a case study questions. The question which is taken here is from the textbooks, and this is the questions. Question this: 200 logs are stacked in the following manner: 20 logs in the bottom row, 19 in the next, 18 in the row next to it, and so on. In how many rows are the 200 logs placed, and how many logs are in the to that row? This is our question. Here the question, in this question, the abstraction is means the important information is taken out. First of all, in the bottom rows, 20 logs are there in the bottom row. That is considered as a first term, A1. Then after, in the second one, that is 19 logs are in the next row. That is second term we consider. And in the third, 18 rows are there. That is A3. A3 is equal to A plus 2B. In the first, 20 logs are there, so that is first term, that is A1. In the second one, 19 logs are there, that is A2, A plus common difference, it is added. In this way, we first write the means the important information of that from that problems. Then after from this data observed, we draw the means the we instruct the student to draw the graph. The graph we draw, on the x-axis we take the number of rows, while on the y-axis we take the number of logs. So first of all, here after drawing the graph, means student draw their conclusion from the observing the graph. Everywhere they found that the length of each bar is decreasing here, and the difference between the two successive bar, here the decreasing, and by 1 unit it is decreasing. That's why the difference between two successive term is negative, and that is minus. So that's why common difference here it is the minus. Since the difference everywhere here it is same, that's why it is in AP. And the sequence which we get, that is 20, 19, 18, and so on. Then after what we did, we write the pattern recognitions. In the pattern recognition, here the first row, 20 logs was there. In second one, 19 logs was there. Next one, 18 in this way. So see here, in the first row, number of means the first row, n equal to we take 1, number of logs was 20. And it was total, so that's why S1 I consider that is 20. Then after, number of two rows, means including first and second. So 20 plus 19, it becomes 39. So it is S2, that is the total number of first row as well as the second. That is 20, and we write the pattern like this way. 20 plus 19, 19, 20 minus 1, this way we wrote. Then third row. So 20 plus 19 plus 18, that is 57. 57 means S3, that is 20. And 19 I wrote 20 minus 1 plus 20 minus 2 in this way. Then after fourth row, so 20 plus 19 plus 18 plus 17. So total it is 74. So it is 74. I wrote like this way: 20, 20 minus 1 plus 20 minus 2 and 20 minus 3. In this way we get the patterns here. Then after algorithm, student design the algorithm of problem solving act. First of all, use abstraction to note down the important information. Then after, identify what to find, number of term or sum of the term from the problem. Then identify the AP, whether it is increasing or decreasing. Then note down the common difference, apply the relevant formula and substitute value add to solve the problems. Here, students are aware about the formula, that is sum of the means the sum of the nth term and the number of nth term. So total number of logs in the nth row, it was already given in the question, that is Sn is given, that is 200, and we directly use the formula here. Sn is equal to n by 2 in bracket 2a plus n minus 1 into t. Sn, its a value was given, that is 200. So n by 2 into value first term, it was 20, that is the number of logs in the first row, it was 20. So 20 I put here. Then after solving this, n minus, here we are finding the value of the n, in which means the value of n we are finding. Common difference, it was -1. After solving that, next step, so 2 into this 200, that is 400, n in bracket 40 minus n plus 1. Then after solving this, we get one quadratic equation. Quadratic equation, that is the n square minus 41n plus 400 equal to 0. This quadratic equation we get. Here we are finding we are solving just like as the quadratic equation by breaking the middle term. Breaking middle term in such a way that the multiplication of first and last term, it should be equal to the multiplication of the, means we are breaking the middle term in such a way that their multiplication, it should be the multiplication of first and last term here. So this way we break the term, that 41n we break in such a way that their multiplication, it is equal to 400n square, and breaking of that 41n, it is equal to minus 14n plus minus 25n. So this way we break the term. N square, instead of 41n, I wrote here minus 25n minus 16n plus 400 equal to 0. So from these two terms, n is taken common, so n minus 25 I got, and minus 16 I taken common, so n minus 25. So two factors I got here. The value of n2 I get, n equal to 16 and n equal to 25. So n minus 16 equal to 0 and n minus 25 equal to 0. So n equal to 16 and n equal to 25. So then after we put the value of n equal to 16 here. When n equal to first, we put the value of 25. So after putting the value of nth term, that is the formula of an is equal to a plus n minus 1 into d. In that formula we put the value. So after putting the values, a25 term, a plus 25 minus 1 into d, so that is a equal to 20 plus 25 minus 1 means 24 into minus 1, that is 20 minus 24. So 20 minus 24, that is minus 4. So here number of logs is not, means the minus 4, it is not possible. So that's why other value we take. So the other value, that is n equal to 16 I think. So here a16, so a plus 16 minus 1 into d. So 20, value of the a, it is 20 plus 15 into minus 1. That here I got the value of a16 equal to 5. So here it is possible. Value of the a16, it is positive. Here it was negative. So that's why I wrote here no. Here it is possible. So S. So what I can say means that there are this way it is given. And other potatoes are placed 3 meters apart in the straight line. There are 10 potatoes in the line. A competitor start from the bucket, pick up the nearest potato, run back to it and back with it and drop in the bucket. This is about the recursion, repetition process till a certain condition is met. What is the total distance competitor has to run to pick up the 10 potato? That we are finding. Same procedure we followed here. Here the distance run to pick up the first potato, that is equal to 5 into 2, 5 meter. So from two sides, this distance, he is picking the first potato, from buckets he is coming here to pick up the first potato, again he is covering the 5 meter distance. That is total distance covered to pick up the first potato, that is the 10 meter from both sides. Then after distance run to pick up the second potato, 5 plus 3, because the second potato, it is the 3 meters away from the first potato. So that means 8 meters from each side. So from both sides, it is the 16 meters, both sides. Similarly, distance out to pick up the third potato, that is 8 plus 3. This distance, it is the 8. This is 8, again it is 3. So means the 11 meter each side, and from both sides it is 22 meters. So pattern, again we run the patterns here, pattern recognition. D1, it is the distance covered from bucket to potato, and D2, it is the distance covered from the potato to buckets. So for the first, to pick up the first potato, 5 meter distance is covered. Again, to drop the potato in the bucket, 5 meter distance. So total distance he covered, it is 10 meter. 2 into 5, that is 10 meter. For second potato, distance from the bucket to potato, it is 8 meter. Again from potato to bucket, it is 8 meter. So total distance, it is the 16 meter. Similarly, for the third potato, total distance here it is 5 plus 3 plus 3, 11, and this 11. It is 2 times into 11, 5 plus 3 plus 3. Means this way 22 meter. So learning outcome by using the pattern recognition. Here we draw the graph to find out the common difference between the two successive terms. After drawing the graph, here we find that each graph here it is increasing. Student draw the graph of following conclusion by pattern recognition. Here student observe the graph and draw their conclusion. So everywhere here the bar it is increasing by 6 units. The length of each bar is increasing, and difference between the two successive bar is the positive, that is 6. So here we get one sequence, that is 10, 16, 22 dash dash, this way. And common difference here it is same, that is the 6. So we can say the given sequence is in AP, and here first term it is 10, then after the common difference between them it is the 6. And then directly we put the values in that formula to find out the distance covered by the competitor to pick up the 10 potato. So this is the formula. We need to calculate total distance run to pick up the 10 potato, that is S10. So Sn equal to, students are aware about the formulas of nth term, sum of the nth term, n by 2, 2a plus n minus 1 into d, putting the values of n equal to 10. A first term they know, that is 10, and common difference it is 6. So after putting the values 10 by 2, S10 equal to 10 by 2, 2 into value of A, that is 10, plus n minus 1 into 6, that is 9. So 5 into 20 plus 9 into 6, that is 14. So we get here the values 370 meter, means total distance covered by the competitor to pick up the 10 potatoes, that is 370. Here some impact we find after means the applying this CT. Here all the 40 students were able to visualize the graph and pattern. 34 students are able to use abstraction correctly. 6 to 7 students still face difficulty in framing algorithm, but we will explain in their word. Learning outcome increased from 60 to 65% to more than 85%, which was very positive. And conclusion, here it is integration of computational thinking with math is very helpful in higher learning outcomes. Teacher presentation is needed. teacher must be well versed and competent enough to identify and integrate CT skill effectively. Thank you.
Yeah, thank you, sir, for the wonderful presentation.
Thank you.
I request you to kindly stop sharing.
Pratiksha ma'am, can I share now? Mamta Kore speaking.
Yeah.
Yes, ma'am.
Ma'am, are you ready? So can we start with?
Yes, ma'am. Is my presentation visible, ma'am? Hello.
Yes. So next we have CT integration in Maths lab activities by Mamta Kore.
Yes. So good morning to.
It's a general request to all. Kindly stick to the timings, time limit.
Yes, ma'am. So good morning to all dignitaries and my dear colleagues. I am Mrs. Mamta Kore, presenting the topic City Integration in Math Lab Activities in the 5th Conference on Computational Thinking Skills. The term computational thinking has gained considerable global awareness in the past decade. Most of the developed countries include computational thinking in their curriculum to enhance student thinking ability. Our Meghe group of schools always takes such initiatives which help students to develop their thinking ability. Has integrated CT in our curriculum from 2017-18. The paper states about the lab activities where students of grade 9 used CT skill, algorithm, pattern recognition, and abstraction. Most of the time, the method followed by the teachers to teach mensuration is directly giving the formula and asking to learn formulas and apply it in problem solving. But we found that with this method, students mix the formulas and loses their marks. So it is rightly said that tell me and I forget. Teach me and I remember. Involve me and I learn. So the maths lab activities conducted. First lab activity is to discover formula for total surface area of cube and cuboid. Given take board box, mark sets red and height and perspective. Color the face of opposite faces with the 3 different colors. Cut out the 6 faces and paste them on a plain sheet of paper. Add the area of all the faces to find the surface area of the cuboidal box. Here, students use statistical decomposition to find the formula for surface area of a finding the area of each face, which is a rectangle. Here they use pattern recognition, that is surface area of any solid is sum of areas of each face. Abstraction, that is as they are using the knowledge of finding surface area of cuboid to find the surface area of cube and cylinder. Second activity was to obtain mirror image of a geometrical figure with respect to x and y axis. Students were given the steps and asked to observe by using this observation tables. So they had to follow the procedure that they had to drop the perpendicular, they have to take the one triangle in coordinate plane
or any figure they can take. Draw perpendiculars from the points to the y-axis and then extend it, these lines to the point A2 dash, B2 dash and C2 dash, so that A2 L2 is equal to L2 A2 dash, B2 L2 is equal to L2 B2 dash and C2 L2 is equal to L2 C2 dash. Then to obtain the mirror image of the triangle, find the coordinates of the points which we have received by mirror image, record them in the observation table. Repeat the activity for more figures to obtain mirror image with respect to x and y axis and record observation in 2 tables. So they have to do it for the x axis as well as for along the y axis. Students repeated the process for square and observed the pattern. The image of any point along the x-axis, x coordinate remains same and sign of y coordinate changes. The image of any point along the y-axis, y coordinate remains same and sign of x coordinate changes. Through the pattern recognition, students are able to tell mirror image of any point with respect to x and y axis without plotting points. The next lab activity was to express the square of the numbers by using Jodo blocks. These for the identity a plus b whole square. Student used here systematic listing and counting for making pair of a and b. So for the square of 5, they made the pair 4 1 2 3. For square of 6, they made the pairs 4 2 5 1 and 3 3. Students' views were taken on the math lab activities. So they have shared, the data was collected from the class 9 students indicated with the help of, so 64 students express that it increases the easiness using the math lab activity. 59% said it is helpful to find geometrical concepts. 74% shared students that it builds confidence. 57% students thinks that it enhances the subject interest. 59% students think it is subject effectiveness. It increases subject effectiveness. Conclusion, we tried to conduct lab activities using CT skills. Students are performing curricular activities using the CT approach of problem solving. Computational thinking allows students to be active learners rather than the passive. Computational thinking encourages children to scrutinize a problem and build a solution for it. These are some references. Thank you.
Yeah, thank you, ma'am, for the presentation. Children must have enjoyed the math lab activities using CT skills. Yeah, thank you.
Thank you so much.
Yeah. Next we have, but before I announce the next presentation, feedback form will be shared with you. The teachers are requested to fill the feedback form. Those who fill the feedback form will be getting a participation certificate also. So next we have presenters from School of Scholars Wardha, Kanchan Janotkar ma'am and Praveena Kamble ma'am. The topic is application of systematic listing and counting in basic operations in primary classes. So over to Kanchan ma'am and Praveena.
Yes, ma'am. Am I audible, ma'am?
Yeah.
Okay, ma'am. please.
Ma'am, please use presentation mode.
Madam, okay. Is it visible, ma'am? Shall I use presentation mode?
Yeah.
With slideshow?
Yeah, yeah.
Okay. Thank you. Is it fine, ma'am? Or
just use F5 button.
Okay, ma'am. Yes. Good morning, all dignitaries and teachers. Here we have here I am Kanchan Thanakar and Pravina Kamle. We both are going to present CTiS skill, applications of systematic listing and counting in basic operation in primary classes. So it is very important to list out and listing properly and counting and making different combinations. So in this CTiS skill, our objective is to apply systematic listing, counting, and making different possible combinations in primary classes. So here we are going to use the approach that is concrete to abstract. As we know that it is very important to for primary classes to start and give concrete object. So first of all, we will start with concrete object. So before that, example will be given to students. It is about for making different combinations with clothes. So here we have, here you can see that there are shirts and shorts and pants. So we have one half shirt and one full shirt. And for that we have here, with that we have 4 pants. There are 2 short pants and 2 long pants. Now student has to make the combinations for these. With this, they have to make combination with shirts, half shirts, and with full shirts also. So here we can see that there are 4 pants and there are 2 shirts. So they can make the combination with the half shirt. They can make some combinations, and also with the full shirt also they can make some combinations. So they have to find out the possibilities here. So here, just like with half shirt, they can make the combination gray shorts, half shirt and gray shorts. Then another one will be with black shorts. Then next one will be with black pant, and then next one will be with gray pant. So with one half shirt, they are getting 4 combination. Just like that, here they have another option, a full shirt. So the with full shirts also they can make 4 combinations. If the condition will be there that they have to use only with full shirt, they have to use only full pant, then it will be little different. So here we have to see the conditions also while making combinations. So here you can see with full pant, with full shirt, we have here 2 combinations with black pant and with gray pant. And if the condition will not be there, so at that time they can make 4 combinations. So here with the real examples, we can start to get them clear. If it will not be clear, just like they are not getting it with, so it is very useful to use the blocks, as it can be more practiced. It is hand-on activity, and student can with interest they can do with blocks. So let's see how they can do it with the block. They have to make different combinations. So, and has to find different possibilities in that with that while making combinations. So here we have 2 sets. We will give this block in 2 sets. In the first set, we will give them a yellow block and blue block, and along with that, in another set, they will have red block and green block. Now, with this, they have to make combinations. So, the possibilities they have to find, the different possibilities they have to find. Just like with yellow block, how many combinations they can make, and with blue block, how many combinations they can make. So here, first of all, we can see that with the yellow block, yellow and red, it is made, and if it is reversed, red with yellow will also be possible. But here it is repetition. Then in next one also, third one, that is blue with red, and fourth one is red with blue. So the combination is same. Then fifth one is yellow with green and green with yellow, and blue with green and green with blue. So here we can see that the combinations are there, but somewhere the blocks are repeating. Some combinations are repeating. So we can tell them to remove that one. So here we are getting the combinations. With yellow block, we are getting two combinations. That is red with yellow with red, and another one yellow with green. So with yellow block, they are getting two combinations. Then we can tell them to, if any more combination is possible with yellow, so they have to do it systematically by listing and doing it properly. They have to see if many more combinations are possible or not. If it is possible, they have to find it out. Then another one is they have to take blue block. For blue block, again they will make two combinations, that is with red and with green. So here we need to tell them to, if whatever the different possibilities are there, that they need to find it out. Now we will increase the difficulty of students. In next one, we will give them, in set 1 we will give 2 blocks, and in set 2 we will give 3 blocks. So in set 1 they have 2 blocks. So first of all they have to make. Now the systematic approach will come here, that with blue they will try the set 2 combination with set 2. Just like with first block, that is blue color, they will try the first combination, that will be blue with yellow. And then after blue with green, then after blue with black. So it will be easy for it will be easy while they will do more practice, they will find it easier to find in a systematic way, and they can list it out. Then after, for blue blocks, they will get 3 combinations, and for pink block, they will get again 3 combinations, pink with yellow, pink with green, pink with black. So here they are getting 6 combinations like this. So with one block, first block they got 3, and with second block also they got 3 combinations. So after using the blocks, we can tell them to find out such examples in real life also, where they can make more combination. We can take out the examples from students also. So they can get examples of clothes, then after food items, color combinations, and different. And then after we can connect it with the numbers. So here over to Praveena ma'am, please continue.
Yes, thank you, ma'am. Ma'am, please change the slide. Once students learn the concept, systematic listing and counting, we have given them the another task. Find all possible combinations for number 10 using pair of numbers from given sets by performing additions. For that, we have given them 2 sets of numbers. In set 1, there are 3 numbers, 4, 5, and 8. And set 2, there are 4 numbers, 2, 6, 8, and 5. Using these numbers, students can make their all possible combination, and they are getting the sum 10. 4 plus 6 is equals to 10.
Using this systematic approach, a student can find different combination by performing addition, subtraction, and multiplication. Ma'am, change the slide.
Yes.
Last. Ma'am, please change the slide. Last one.
Yes, I have shown. It is present there. Present there. Are you getting it? Worksheet.
Yeah. No, next slide. Slide number 10.
Previous one.
Slide number 10. Yeah, after applying all implementation, we noticed that a student listed and counted combination systematically. Students were able to apply CT scale like listing and counting in real life situation and in mathematical concepts. This module to increase the confidence among the students while making listing and count real life. Thank you.
Yeah, thank you, Praveena ma'am and Shadi ma'am. Can you please stop presenting? Yeah. Next, we have the presentation from Anita Pawar ma'am, Ashwini Utkede ma'am, Rajeshri Saraf ma'am from School of Scholars, Kolkhed, Akola. The topic is activities to enhance CT skills. Over to Anita ma'am.
Good afternoon, ma'am. Anita madam is not there due to some reasons, so I will be presenting.
Okay. Kindly stick to the timings.
Yes, ma'am. Yes.
Ma'am, you're on mute.
Oh, so sorry. So good afternoon to one and all. Topic which I have chosen for paper presentation is activities to enhance the CT skills. As we all are listening since morning that the many mathematical concepts have CT skills integrated in it. So here I am trying to present one of the concepts from 9th standard and 10th standard where CT integration is done. Earlier, the topic was taught in a different way, like by traditional method by teachers. But then after using the CT skill, it has given a different insight and approach to teachers as well as to students to learn and teach this concept in a different way. The activity conducted was finding the geometrical meaning of zeros of polynomial. Basically, how do we find the zeros of polynomial by graphical method? So for this activity, the class was divided into group and each group was given 4 to 5 examples of similar type. Like here, group 1 was given the examples polynomial, linear polynomial, where students are asked to do the graphical representation by finding solution. So students have obtained the solution for each of the equation polynomial they have and they have represented it in form of graph. After drawing the graph, students are instructed to do some observations and note it down and then make the generalization based on their observation. So here one of the example is shared that from this graph student have observed that the graph y is equal to 2x plus 3 has intersected the x-axis between x is equal to -1 and x is equal to -2. That means it has intersected at one point only. Therefore, that point of intersection of line with x-axis is the zero of the polynomial y is equal to 2x plus 3. So students have tried different examples of similar type, noted their observation, and then they did the generalization that the zero of linear polynomial is the x coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. And on this basis, they have concluded that linear polynomial has at most 1 0. So this was the observation and the findings and generalization done by group 1. Then second group has given the polynomial of second type, that is a quadratic polynomial. Y is equal, one of the example is y is equal to x square minus 3x minus 4. And students shared their observation that this polynomial has the zeros as -1 and 4. And the zeros are the x coordinate of the point in which the graph intersects the x-axis. And the generalization made by the students that the graph cuts the x-axis at two distinct points. So the quadratic polynomial has 2 zeros. In general, the quadratic polynomial has at most 2 zeros. The third group have given the third type of polynomial, that is a cubic polynomial. They have also shared their observation by drawing the graph that the 3 zeros of the polynomial are -2, 0, and 2. So the graph cuts the or intersects the x-axis at 3 distinct points. So cubic polynomial have at most 3 zeros. So in general, the polynomials of degree n has at most n zeros. So such a abstract concept was performed through the activity, and students have understood the abstract concept in a easy manner. Then one more activity for class 9th was conducted that was based on algebraic identity, where the puzzle is created for the student, and this puzzle is prepared in form of template as it is shown on the screen. So in this template, there are the standard form of the identities and expanded form of the identity also. Students were supposed to cut out this template into small triangular pieces, and they were supposed to put them in the pattern which is shown here in the next figure. So here students have done the small triangular pieces, and then they have done the systematic listing and place the triangular pieces to complete this design. So in this way, standard 9th and 10th student have performed these two activities where they have used the CT skills like pattern recognition, then generalization, and systematic sorting and combination is used by student for completing these two activities. Both the concepts were very difficult and abstract to explain it just by the theoretical method. So with this activity, we find it very easy, and students have also enjoyed performing this activity. So impact which was seen as all 40 students were involved, and they were actually able to visualize the abstract concepts and drawn their conclusion based on their observation. Apart from these activities, students are now using the CT skills, like different CT skills, like using algorithm and abstraction for solving word problems, algorithm for operations on fractions, integer, and decomposition in solving questions based on BODMAS, pattern recognitions, and finding the rule and generalization in framing algebraic expression. So that's all from my side. Thank you for giving me a chance to present and share my idea in this conference.
Yeah, thank you, ma'am, for the presentation. Can you please stop sharing?
Yes, ma'am.
Yeah. So now we have with us the principal from School of Scholars, Amravati. So sir will be sharing his experiences in implementing CT in the schools. So over to Suresh Lakade, sir. Thank you.
Thank you, ma'am. Am I audible?
Yeah, you are audible.
Yes, sir.
Okay. So very good morning to all. especially Director MGS, Ava Meghe ma'am, Dr. Ramanujam, Sonia Garche ma'am, and then Resource Center Head Geeta ma'am, and all the members who are presenting the papers in Meghe Regional CTiS 2023. I am glad to share the implementation of computational thinking in our school. School of Scholars Amravati is Guinness record holder and best CBSE school in the city. We are facilitating nearly 3,200 students from nursery to grade 12 to nurture their future. And we have around 116 teachers in our school to enhance the academic and problem solving skills of the student for the future challenges. Everybody knows the objective of CSPathshala. Curriculum is basically to integrate computational thinking skills like abstraction, problem solving, critical thinking, and algorithm among the students and make them ready for the future challenge. It is a pleasure to share with all you that we adopted a CSPathshala curriculum in our school in 2018 by integrating computational thinking in maths and ICT. Our teachers were first trained by the CSPathshala team and by our resource center. Our academic head Geeta Ghormade played a vital role in bringing and executing the CS curriculum in all Meghe group of schools. Especially in Amravati, we are running CS curriculum successfully from 2018, and I'm happy to share with you all, gradually the tree has started growing and bearing the fruit of the desired outcome to a remarkable extent. Initially, we faced some challenges like making our teachers friendly with the curriculum and make them realize the importance of integration of computational thinking skills in enhancing the academic standard of our school. But within the due course of time, now our teachers have adopted it to the fullest and have started the integrating this CT skill in their routine teaching. In our school, we have taking a CSPathshala activities which are already integrated in the annual curriculum plan in the allotted periods, and at the same time we conduct these activities during the special days like Maths Day, Science Day celebrations, and on the days of parent teacher meeting also. We exhibit them on the open house day so that the parents also get the glimpses of CSPathshala curriculum, which is the unique feature of our school among the School of Scholars Amravati. This exhibition and activities are open for the teachers, students, and parents as well, and students and teachers parent to exhibit the stall in different games. CSPathshala activities, behavioral challenges, questions, Sudoku, etc., and also love to participate in these activities. At initial stage, we adopted in maths and ICT, but now we are trying to integrate with other subject too. And our teachers from maths and ICT department have presented their paper in CTiS conferences based on their experiences. Under the guidance and support of Resource Center and HOD, our teachers are now able to identify and integrate the topics from maths curriculum with the computational thinking skill. In departmental meeting, they sit together with the textbook and identify the topics which can be interlinked with CT skill and make them easy for the students. Algorithm provides step-by-step approach of problem solving, and this is useful for the solving problems from SCF, or we can say LCM, operations of fractions, rules of integers, systematic listening is useful in probability questions like writing learning outcomes when 2-3 coins are tossed together, etc. Sudoku activities develops systematic approach for the problem solving. Usually, the student approach the problem in a random way, and hence it is uncertain to reach the solution always correctly in allotted time. Hence, the systematic approach helps them to reach and problems of similar kind of following the systematic approach. Teachers integrate abstractions in teaching word problem and facilitate students to focus only on important information and eliminate the unwanted extra information given in the problems. This saves the time of students and they develop the habit of using abstraction in long word problems and case study based question. This has helped students a lot and we have really got awesome results in the mathematics of grade 10 batch 2023. Out of 266 students, around 119 students score above 80% mark, which is the highest number from all the subjects. And this year and previous batches too. 5 students of current year score 100 on 100 in mathematics and the learning outcome is increased around 10% in all grades in mathematics. The phobia subject is now turning into the subject of interest is the biggest achievement. And so we are witnessing a growing graph of the result and learning outcome after adopting CS curriculum. I am sure that we will maintain the growth graphs in future too, and our students will be ready for the facing problems, solving challenges by the developing critical thinking and problem solving skills through the CT integration. Finally, I would like to thank Team CTiS for a wonderful initiatives and thank you and wish you all the good luck. Thank you.
Thank you, sir, for the encouraging words. And I think the teachers will be inspired to do more with your encouraging words. Thank you once again.
Thank you, ma'am.
So let's begin with the next presentations. Next, we have CT in Science Education, under which Rita Panse ma'am is going to present. She's from School of Scholars, Vanadongri, Nagpur. And the topic is computational thinking involved in designing a model of hydrocarbons. Over to Rita Panse ma'am.
Yes. Yes, ma'am. Am I audible?
Yeah, you are audible, ma'am.
Yeah. A very good afternoon to all the dignitaries and my dear friends. Today I'm going to present a paper on CT integration in science. Till now, we all were listening about the CT integration in mathematics as well as ICT. So while integrating CT in mathematics, it seems to be very difficult, and how to implement the same thing in science, that was little bit difficult for us. Even when we have thought of implementing this, we were thinking how we will be able to do this. But still, when we have gone through the, I'm just sharing my presentation, ma'am. Yes. When we have gone through the CT skills, which we can easily implement, so I have thought of, let us bring this project and simplify the project for the students through the CT integration. And I have tried. So this is our project. This is the activity which was given to standard 10 students for designing a model of hydrocarbon. As you all aware about the curriculum of standard 10th, that they are having the lesson carbon and its compounds. So it is very common activity which can be given to them. So designing a model. But if this is an activity performed by the students individually, so definitely they are going to find it very difficult that which model they need to design and how they'll be designing. So for that reason, we have fall back on this concept of CT, where the first task for the students was to identify what exactly is asked. They have gone through the hydrocarbon family, where you will find n number of compounds with variety of their properties, structures, bondings, and everything. So when such a huge family is available, you need to take an appropriate molecule or a compound which you want to design. So that was a very difficult task for the students. So when we are identifying that what is given to us, we have tried, or children have tried to decompose the task by selecting the correct hydrocarbon. Like, suppose in case of hydrocarbon, if you are thinking about alkane, alkene, and alkyne. Alkanes are the single bond compounds. Here I have few models with me, which are designed by the students only. So they are the single bond compounds. And when these single bond compounds are, is it visible, ma'am? Is it visible?
Yes, ma'am.
These are the models which are designed by the students. So when you are talking about single bond compounds, they need to know that what is the geometry of carbon molecule, which is present in the center, which is actually a tetrahedral geometry having, and 4 valencies of carbon are directing towards the 4 corners of tetrahedron. So this was the concept which they need to understand. Once they have decomposed the problem and they have decided that yes, I am going to prepare all alkanes which are having only a single carbon-carbon bond, then they are very much focused. They have ignored rest of the options for double bonds, option for triple bonds, and all these options, and they are focused on single bond compounds. So likewise, this is a single model, first member of this series. Then they have prepared, this is second member of the series, which is having 2 carbon atoms with the same geometry. Okay, likewise 4 valencies, 1, and other these 3 valencies. So they could prepare a model for ethane, that is a molecule having 2 carbon atoms with them. This is a molecule with having 1 carbon atom with them, and likewise propane, butane, and likewise. So here what they have done, how they have applied here CT skill, they have first identified the task, then they have decomposes the problem, then they have abstract whatever is not needed. Suppose I am a student and I want to prepare only single bond compounds, I'll focus on this. So rest of the options of double bond and triple bond are not open for me, that I have abstract. So this is how the third option of third skill of CT is implemented, abstraction. After that, pattern recognition. Yes, they have decided to prepare alkane. Now they have to think about the bond which they are going to prepare. What type of bonding is there? What type of pattern every carbon atom is following? So here in every molecule, they are trying to arrange the carbon atoms in a tetrahedral shape. So this pattern is followed in all set of alkanes which they are going to prepare. So here the pattern recognition comes and implementation is also comes. Then algorithm. Now once the compound is identified, abstraction is done, pattern is identified, now they need to sequence, they need to prepare a stepwise approach reaching to the solution. Now they have decided, yes, I'm going, which atom and which carbon atom should be how big, and how I'm going to show what should be the bond length. So stepwise they have prepared their mechanism and then started implementing and designing each model of hydrocarbon. Here I have few images of the models, and even I have attached one video also where every student has prepared their own model. It is not like that they have prepared only hydrocarbon with a single bond. They have prepared hydrocarbon with double bond also. So I have this type of double bond model also, which they have created. They have recognized the pattern. So in this way, this CT is implemented. Definitely, every activity when you are trying mathematics, we were considering CT very easy and aligned with the mathematics. But in science, we were finding it difficult. So of course, there are challenges for the students as well as teachers also. So the first challenge was selecting a model or a structure to be made. How I have to select? I should know the knowledge. I should know how is the carbon atom. Then second is selecting a material for preparing a model. I have a best example that children have started preparing their model by using clay material. We all have seen clay is little bit heavier. When you go for 3D structures, which is having little bit height also, strength also. So in such condition, to make these structures stand erect like this, it is very difficult with a clay model. So because clay is like very, very heavy. So they have tried first with clay, and then they have tried with this another option of aluminum foil. Here again, they are kept in mind that yes, each carbon atom in the structure, this is the structure of diamond molecule, which is a pure carbon compound, and they have designed such type of structures by using the next material, which is an aluminum foil, which can provide the strength to the structure, and they can build at least 4 to 5 carbon atoms in a combination. So here they are learning that which material is right and how I am going to work on it. So this is also again one of the difficulty which they have faced, one of the challenge which they have faced. Then visibly, when I'm designing a structure, every atom, I'm talking about 3D model, so every atom should be visible. That was the challenge while designing a structure, because many students were thinking of 2D models. So where there maybe they are not able to show the bonds which are present on the back side. But when they are designing 3D models, they should be very, very focused for the visibility of bonds and atoms. Then engagement of all learners. Initially, it was like that, one child is working and others are just observing them. So we have to take care as a teacher that every child should reach to the right solution. So that was again a challenging for the teachers as well as students to keep them engaged in the activity. The next thing was impact. Yes, I found that after this activity, this is not a new activity what they are doing first time. They are doing, maybe the many batches have done the same thing, but now their problem was little bit solved. Now they are learning the methodologies of decomposition, abstraction, algorithm for solving a problem. Similarly, the activity was not to explore the material, but indirectly they have reached to that also. Means not only the engagement of students for making model was there, but research activity and exploration was also there for the different type of material, and until and unless they get satisfied, they could not model it correctly. So that was the best part, and now I found that everybody was engaged in the activity. So this is how I am very much satisfied by implementing this CT approach in the formation of hydrocarbon model. So here I have attached one video which will give you a glance of all the models which are prepared, and let me discuss this future scope also. It will be definitely implemented. Now it is started in science in our school. So earlier it was for mathematics and computers, but now we have started with science. So definitely I try to apply and tell my staff also to implement this in while carrying out science practicals for 9th and 10th, and as well as sample analysis in grade 12th. Just have a small look overview of these models which are already made by the students in our school campus. Just 1 minute it will take. I'll just remove it fast. These are the various models which are prepared by the students, and of course it is a part of their curriculum. So it was very easy for them to learn through the experiences. Now no child can say that ethane is having a double bond because they have prepared a model. This is the structure of graphite, which is a 2D structure. What are hexagonal arrays? They come to know. So this is how they have implemented. These are the various model. And then again, triple bond molecule. They have tried to make it with plastic balls and straws. Yes. So this is how it is very easier for the students, and in practical, definitely.
Sorry to interrupt you. Your video is not.
It is not playing,
yeah.
ma'am.
Yeah.
Is it visible, ma'am?
No, I think you have shared the presentation only. Video is not visible.
Okay. 1 minute.
It's okay if the video is not also shared.
Just a minute, ma'am. It's done, almost done. Is it okay now?
Yeah, we can see.
These are double bond molecules. First, they have tried with 2D. These are the hexagonal arrays. This all comes through the systematic approach of the students towards the problem solving. And thank you very much for giving me a chance for presenting this CT skill in science. Yes, that's it from my side, ma'am. Thank you.
Thank you, ma'am, for the wonderful presentation. Yeah. Can you please stop sharing?
Yes.
Yeah. Thank you, ma'am. It was quite wonderful to learn such a difficult topic, which especially I found it difficult in my school days.
Okay.
Thank you.
Yes, thank you.
So let's now move to the next presentation. The next is CT in science education. Let's enjoy science with CT. The presenters are Anagha Lothe ma'am and Shireen Qureshi ma'am from School of Scholars, Kolkhed, Akola. Over to you, ma'am.
Thank you, ma'am. Very good afternoon to all the dignitaries and my dear friends. We are here to present our presentation on the theme CT in science education. And the title is Let's Enjoy Science with CT. It must be more appropriate if I am writing Let's Enjoy Learning Science with CT, right? So let us just move to our concept. Let us just have a small insight over the concept. What is computational thinking? For science teachers, it must be revised again and again because we have started using it recently. Because we are provided with some very useful programs like Ignite My Future and Treasure Hunt and all related to these things. So I'm very much thankful to the management for providing us with these things. And let us have a look over what is computational thinking. Computational thinking refers to strategic thought and problem solving through algorithms or other steps that could be completed by a computer. Means you can compare yourself if you are following CTiS skills with a computer, how the computer would be doing. We are only following the same things with some different terminologies, right? So it is also, in a simple way, we can say it is a kind of thinking that breaks things down into parts, refines processes to become more efficient, and identifies helpful patterns. There can be CT implementation in our day-to-day life. A very simple example I have given here is organizing a long to-do list into manageable daily tasks, which we people have to follow every now and then. There are so many other examples implemented, like reaching to a particular place involves CT algorithm and all. Now, how it is implemented in science? This is our day-to-day life examples. Now, let us move to our particular subject, science, where this implementation of CT can be achieved in various ways, in various subjects maybe. Like if you want to draw a ray diagram, it will be definitely helping you. Decomposition would be helping you. Abstraction would be helping you. Proper terminologies to be used and a step-by-step approach required for drawing a diagram in physics. That is the diagram for image formed by a mirror or a lens can be a way where it can be used. It can be even used in biology for describing a process which is a very complex process, that is double circulation, which involves different chambers of the heart. The flow chart can be utilized wherein the way of blood can be explained. And obviously in chemistry also, which the topic which we have taken for our explanation is IUPAC nomenclature. This is found many times the students may be finding it difficult to write or to draw the structure from the given information. So we have just focused on one part of it, that is the IUPAC nomenclature. So the example of nomenclature is executed in the class with the help of CT skills. Now my colleague, Ms. Shireen Qureshi, she will be explaining how we have done it in the class. Ma'am Shireen.
Yes, ma'am. Thank you. First, we have started with the brainstorming activity of writing the IUPAC nomenclature and drawing the structure from the IUPAC name. So we have provided a set of questions based on the same to the all students, and we followed by the discussion on the algorithm. Various steps we have discussed how to decompose it, how to identify the constituent attached to the particular examples, and then we students supposed to compile all the data and have to write the particular solution or the particular nomenclature, give the nomenclature to the particular structure. So after the discussion of all the algorithm and all the steps, the students were randomly called on the blackboard and asked to write down and followed all the steps which we have discussed. Equal opportunities given to all and every students just to write down and just to follow the CT skills to fulfill the desired outcome. And we to ensure our outcome, we have twisted the particular question. For example, if you will be giving the example of 3,3 diethyl pentane, it can be drawn, if you will be using a bond line formula, it can be shown as a swastik symbol. So instead of writing the complete formula, we have drawn the swastik symbol, and the students were asked to complete the name or write a complete particular name. This was the activity given to the students. Definitely, at the beginning, we have faced the problem, practical issues and time-consuming issues. First, the sort of fear we have seen among the students while they heard the topic nomenclature. But after applying the CT skills like decomposing and algorithm and pattern recognition, the students were able to find out all this. First, we have faced the problem that most of the students were unable to recognize or identify the particular parent chain. They along with the functional group, the priority orders, they have given the wrong priority order to the functional group. These many practical issues which we have faced while we are dealing with the particular topics.
Yes. Yes. Further, there is a common issue, that is students' interest should be aroused whenever we are discussing any of the topic. So students must take interest in solving such kinds of problems. So, and that too with a stress-free mind. CT has helped a lot in this. They used to see just the problem and get confused on how to do it and what has to be done. But once they are much aware about the steps to be followed or how to decompose that big problem, how to solve it by following algorithm, maybe identification of the pattern would be helping them a lot. These things, when we focus or when we hammer these things repeatedly, so they could understand, yes, these can be the simple steps that can be followed to solve such kind of problems. So that time this issue was solved up to much extent. Time constraint was another thing, that we have to go with a specific structured curriculum planning, and we have to complete all of the things within the given time. But then at some extent, pattern recognition would be helping in just identifying the pattern of questions asked. If you are given a set of questions, so they could identify this kind of questions would be under this type of question, and these few questions would be solved with the help of certain steps, whatever are explained by the teacher. So grouping of the questions might have helped them a lot to come out of this problem of time constraint. Once a pattern is identified, these are the solutions to be followed, and they followed it easily and could manage with this issue as well. Let us move
for example, the example is already given on the screen, on the blackboard. The formula is written over there, and the student has to decompose it, and they have to given the nomenclature. If we will be focusing on the second rule, if they have to numbering it while selecting the parent chain. It can be done via 2-3 ways. Means longest chain along with the functional group, or a long chain without a functional group. So here the students has committed the mistakes. They have selected the wrong chain, and they have selected the longest chain without the functional group. And priority order may be changed. This is one of the challenge which we have faced during this topic. Then impact. Definitely, the effect was visible in terms of confidence shown by the students while solving such a problem on the blackboard in front of all the peers. I have captured the video of students which I want to share with you all. Just of 1 minute.
Seeing the root word, that is hex.
I hope it is visible.
Six columns.
Yes.
1, the functional groups, that is 5 methyl, that we'll be adding methyl on the 5th carbon, that is 1, 2, 3, 4, 5, 6.
Here she is just decomposing the particular nomenclature and trying to draw the structure based on the given name.
And then like we can see, there is a double bond on the 3rd carbon. So we'll be adding a double bond over here, and we'll be adding OH, that is alcohol, on the 2nd carbon. That is OH. Then we'll be satisfying the valency while adding hydrogen, that is H3, and here H. Here we'll be adding H, again H.
Now she is satisfying the valency of carbon.
H3. Here the valency is satisfied and the name is written in this formula.
This is the impact of applying the CTiS skills like decomposition and algorithm. They have decomposed the particular molecules, and then they have followed the all steps and then compiled all the data collected, and then they have given the structure.
We seen the root word, that is hex, which will be 6 carbons. 1, 2.
Ma'am, we can.
Yes.
I think you have already shared the book here.
Yes. May I continue, ma'am?
Yeah, please.
So it was the outcome in the terms of academic excellence or in the term of academic. But here, apart from that, we could formulate few more impacts, like whenever we are teaching. So we need to think of the paper pattern as well, and we have to think of Bloom's taxonomy. We have just tried to link this computational thinking skills with Bloom taxonomy. How is it going to help the students to achieve this, or how it is going to help us to frame a paper or that particular concept in a form of Bloom's taxonomy. For example, if a computational thinking is there, it could be decomposition. The computer may be doing it as the definition of the problem. We can make it in the form of Bloom's taxonomy, that is breaking down information into component parts. If it is pattern recognition, that is, and the abstraction would be helping in generating the things. So it would be helping in understanding what the facts mean and recognizing and recalling the facts, that we call it as a remembering and understanding sort of things. And if it is algorithm, then algorithm means following step-by-step approach or showing a step-by-step approach. So that would be brought into action. So how it would be done? It would be done by judging the value of information or ideas, maybe evaluating the things to solve the problem, and maybe applying the facts, that is application, applying the facts, rules and concepts and ideas in problem solving. So we have tried to just link this computational thinking with Bloom's taxonomy for problem solving. So this way we have tried to implement CTiS skills in science as well. That is all from our side. Thank you so much.
Yeah, thank you so much, Shireen ma'am and Anaga ma'am. It was a wonderful knowing how you can integrate IUPAC with CT.
Thank you.
Thank you. Next, we have a presentation from CT in Social Science Education. It's Political Regimes Around the World by Karuna Galgale ma'am and Sab Banerjee sir from School of Scholars, Beltarodi, Nagpur. Over to you, sir. Sir, you're not audible. Can you please unmute?
Good afternoon, everybody. All the dignitaries. I am Karuna Galgale, and along with me, Utsab Banerjee sir, We are presenting on the topic political regions of the world. Am I audible? Hello?
Yeah, you are audible. Yeah.
Thank you. So we started this topic when it was actually subject enrichment activity. And as we are knowing that always political science is that subject which is difficult for the students to understand, and they actually grapple with the subject matters. So to simplify the concept of forms of government, we utilize the CT skills like decomposition, abstraction, pattern recognition. Now I hand over to Utsav sir. Sir.
Hello, am I audible?
Yes, you are audible.
Yes. Okay. Most of the time we find that in political science, it is very difficult because it's constantly changing. And because it is changing, it gets more and more complicated for the students. So the students, whenever they heard from the news or from various sources, like either from televisions or either from newspapers, they find it that whatever they are studying in the book may not be in the future after 1 or 2 years because of elections, they may be changing. Maybe the leaders who are establishing those systems are constantly in a state of flux. So because of which the students, in order to identify their various forms of government, we told them what are the various types of CT skills that they can use it during the times of presentation. And using those CT skills, they are able to identify the forms of government. Next slide, ma'am. So in order to implement this, first and foremost, we selected the topic. So the topic that selected was the political regimes around the world. And in that, we wanted to identify the various forms of government of various countries around the world. We specifically given 5 different countries of USA, UK, France, India, and China. In order to know about each of these countries, we divided the class into various groups. In order to, and we have given those particular countries to that particular group. For example, if there are 5 students in group A, so we have given group A students have given the country of France. So the entire group of A of all the 5 students will know and search about details from internet and from various sources through about their various forms of government. So they take all the data from this, and like that, number of groups have been created of all the various 5 groups have been created of those 5 different countries in that class. And after taking these groups, after making these groups, we have given them respective countries, and those respective countries, the students take data about their entire political system. Now, as you know, in Google, whenever you search about the political systems, there is a huge amount of data that is being there. So because of that data, it sometimes may get complicated, sometimes maybe not able to understood what is important and what is not important. And sometimes it gets so complicated that they are able to talk with the teachers about what should we take. They take certain guidance about it as well. So that is why, in order to take that data and to know about those specific data, what we have asked for, so they started to have a discussion not only with the teachers, but along with their peers as well in that particular group. So after taking that discussions, they take out all the information and they wanted to make a questionnaire on it, through which we get the abstraction as well. So through that questionnaire, they found out a particular pattern that has been given through those analysis done by the student as well. And in that analysis, they're able to identify a number of things which we will be showcased by my colleague. Thank you.
So challenge faced. As sir already told, that students collected a lot of data, but it was very difficult for them to abstract that data. So we find out the solution on that. That was actually challenge for us, how to abstract that data, because now students aware about all the 5 countries political system. Now in that only particular data we want, on that basis they are going to find out forms of government as well as types of government. Now to abstract that, Also, we want pattern recognition. So we want that data in a particular manner that people, that students should write that data in such a way that they can identify the pattern as well as on the basis of pattern, they can identify forms of government and types of government. So it was very difficult task for us. Then we find out one solution. We prepared a questionnaire. In the questionnaire, we only selected questions we put, which give the answer of that. From that question's answer, they can find out actually which type of government and what is the form of government. So we selected question like who is the head of the government, or the power exercised by. So all the countries. Now it was again difficult if students are writing question and answer, then it was difficult. So we another find out the solution for that. We make it in a tabular format. So in this way, what happened? Key student can compare France, Britain, China, USA, and India. So all the countries were easily compared, and they can they create a pattern, and through that pattern, they started analyzing that this country is democratic or non-democratic. For example, I'm giving question number second, that head of the government is appointed by. So member of National Assembly in France, Britain, it is by monarchy. Then members of parliament in China, USA, Senate, and India parliament. Now, on this only one question, you can't decide that whether the country is democratic or not non-democratic. Another question we put rule of law. So we observe that in that France equal before law, Britain equal before law, China unequal because Communist Party is above all the law, and USA again equal before law, and India equal before law. So these two and three points get us idea that the country like France is equal before law, as well as there is parents represent actually countries representatives are there in National Assembly. So this is that country which is democratic. Whereas if you will see China, the pattern we can see in China, Communist Party is above the law. It means it is not the democratic country. So in this way, we are able to find out the exactly what is whether it is democratic country or non-democratic country. Even forms of government, in that also we put the question like head of the government. From that we understand that president and prime minister, which is the head of the government, and Britain prime minister, then China president, USA president, and prime minister. So from these questions, all the questions, students find out that whether it is semi-presidential government or constitutional monarchy. So through this tabular format, student come to an conclusion that which country is a form, what type of government, and what is the form of government. Both the things they can easily find out. Now over to Utsav sir.
Yes, ma'am. So after finding out, so what is the thing that they get? What is the conclusion? What is the impact that the students got? What we find is that students were able to identify the various forms of government, whether it is for USA the presidential system, or for the India the parliamentary system. For Britain it is a constitutional monarchy, and for China it's an authoritarian government, a form of dictatorship that you can also call it as well. Whereas in France it's a semi-presidential system, as we have seen in the tabular format, that the head of the government is both the prime minister as well as the president. That is why it's a semi-presidential system that has been there. So all through that tabular format, students were able to get that information, and not only that, they were also able to identify how to analyze those countries on the basis of democracy or non-democracy. For example, in China, there is a constitution is there. So just because the constitution is there doesn't mean that it will be a democratic country. So because how you follow the laws, the way that it is being given, is there equal status that is being given, as we have seen in China in the table, that in China there is no equality before the law. So it cannot be called as a democratic country, even though it is mentioned in the constitution. So just because there's a constitution is there doesn't mean it's a democratic country. So the students were able to identify how to analyze a country which is truly democratic and which are the countries that are not democratic, even though they may proclaim as a democratic country, but in practice they may not be a democratic country. So in order to analyze those things, through those techniques, so they have understood various types of city skills like abstractions, decompositions, and various other aspects. Along with it, they have also used the various 21st century skills like creativity, critical thinking, and many other things, as well as data analysis and various other problems. So as we have seen in the Google, so many informations were there. So all those data analysis and everything, all are 21st century skills which has been adopted by our students. And through those skills, they were able to come to the conclusion that the respective countries which are following a particular form of government, whether it is a constitutional monarchy, parliamentary, or a presidential system of government. So all those things have been find out by our students through this subject arrangement activity given by us, me and Prona ma'am. So this is our presentation.
Not only this, but now students can identify words any country's form of government as well as type of government. Only given countries only not. So now they are able to do that words any of the countries finding. Thank you.
Thank you, everyone.
Thank you, Karuna ma'am and Utsav sir. It was really wonderful to know how CT can be implemented in even social studies. Thank you. So
thank you.
Next we have a presentation from Madhuri Khandar, Shilpa Patil ma'am, and Suvarna Kade ma'am from FOS Amravati. The topic is impact of CT activities on student learning. Over to you.
Good afternoon, all. Should I share my screen, madam?
Yeah, you can share.
Yes, 1 minute. Is my screen visible? Hello?
No, your screen is not visible.
Not visible? 1 minute. Is it visible now?
Yeah, we are able to see.
Yes. So, good afternoon.
Please
all.
use the presentation mode.
Yes, yes.
Yeah.
I am Madhuri Khandar from School of Scholars, Amravati. The co-authors are Suvarna Kade madam and Shilpa Patil madam. Both are absent for some other reasons, so I'll be presenting the paper. My topic is impact of CT activities on students' learning. So for standard 5th, we have conducted the activity for making patterns using motif, tessellations, turnings, and reflection symmetry. And we found that out of 40 students, 22 students created the patterns properly. 10 students can explain but cannot create properly. And 8 students tried but not up to the mark. Then we have discussed the word problems. We find that the word problems, especially for perimeter and area, students are facing problem in this. So I use CTiS skills in that. The CTiS skills are decomposition, that is breaking the problem into smaller parts. So I have taken here one example. A gardener wants to fence a circular garden with diameter of 21 meter length of the rope. He needs to purchase, if he makes 2 rounds of the fencing, also find the cost of the rope. If the cost is rupees 4 per meter. So we have used here the CT skills decomposition. Madam, just a minute. Let me share my screen again. So we have used here the status scale decomposition, that is breaking the problem into smaller one. So here fence means students needs to interpret that this is the problem for circumference. The second part is to find the length of rope for 2 rounds, and the third part is to find the cost of rope. Here is the student work abstraction. Abstraction means skipping the unnecessary information and extract the relevant information. So students has written there the abstraction that length of the fence of circumference of the garden means circumference. Then diameter is given here 21 meter. We need 2 rounds of the fence and the cost per meter is ₹4. So students have written the algorithm for the same. So when diameter 21 is given, so first step is to find the circumference by using the formula C is equals to pi d. Once you get the C, circumference means length of the rope required for 1 round of the fencing. Then next step is to find the length of the rope required for 2 rounds of fence. And the third step is cost of the rope per meter. Cost of the rope when the cost per meter is given ₹4. So stepwise students solve the problem using algorithm. So in the class of 42, we observed that 20 students can explain and write properly, whereas 12 students can explain but could not write properly, and 10 students tried but it was not up to the mark. Another activity we have conducted is Sudoku. Here also we have applied CT skills like decomposition, algorithm. We have used 6x6 Sudokus and 4x4 Sudokus. So decomposition means breaking the Sudoku into smaller mini grids and applying the algorithm to solve it. And we observe that for 6x6 Sudoku, out of 42 students, 25 can solve correctly, 12 can solve partially, 5 tried but it was not up to the mark. And for 4x4 Sudoku, 37 students out of 42 solved it correctly and 5 students solved it partially. These are the glimpses. Students made algorithm not for just math, but they made algorithm for science also, for the food chain. Then students made Sudoku using the homemade utensils also, and they created the patterns using turnings. Now the challenges faced. Some of the students took more time to learn, and also on teacher's side, we face shortage of time. Sudoku requires patience. So every student could not solve it within few minutes because it requires time, patience, and attention. For algorithm, we face the problem when students skip practice because of the absentee. Impact. Students happily solved CSPathshala worksheet, especially 04 IPP 01, as it contains number patterns, shape patterns, and all. Students enjoyed thinking rationally. Maximum students could do it correctly, and their computational thinking skill was observed as enhanced. Techno-loving students really enjoyed CSPathshala as they were eager to learn through ICT. CT activities made significant contribution to students and mathematical attitude. We confirmed the knowledge of the students through worksheet, online games, their scores and responses in the class. Students learn to do things quickly. Solving Sudoku puzzle increases concentration power, keep them active and boost up their confidence. Students learned an interlink algorithm with other subjects and activities. Students solved word problems correctly using algorithm for perimeter and area spatially. Students' city activities motivated slow learners to develop mathematical interest in playway method. Thank you.
Yeah, thank you, Madhuri ma'am, for the wonderful presentation.
Thank you, ma'am.
Next, we have a presentation from Jayashree Thakur ma'am and Sheetal Manohar ma'am from School of Scholars, Atre Layout. The topic is fun with patterns. So over to Jayashree ma'am.
Yes, ma'am. Ma'am, is our screen is visible?
Yeah, it is visible.
Good afternoon, everyone. I'm Sheetal Manohar.
I'm Jayashree Thakur
from School of Scholar Atre Layout. Our topic is fun with patterns and coding. Computational thinking helps us to break down the problem into a smaller parts so that it is easier to understand and solve them. School always emphasizes on developing the problem-solving skill to help the student to solve the problems in all areas in life. Pattern recognition in computational thinking uses the identification of similarities within a particular data set or a sequence to simplify understanding and resolving the problems. It is the most interesting thing which gathers the students' attention, which we observe in our maths class. May it is the pages of the notebook, or the designs on the pencil, or the lines on the scale, or even the patterns on the window grills, the student enjoys studying all of them. We have chosen the clapping activity for standard 1 and 2 students. These are the foundational years, and the students enjoy performing physical activities. The purpose of choosing these activities was to develop the CT skill among the students right from the foundational years. The teacher first tells the student to observe the pattern in which way the teacher clapped. Then the teacher asks the student to clap with the different patterns of their own, like 1-time clap, 2-time claps, 3-time claps, and so on. Innovative ways of teaching patterns through the sounds can be observed in rhymes, sounds, and tables, and so on. Likewise, Old MacDonald had a farm, E-I-E-I-O. In this, the student could identify the rhymes in which the sound was produced, which is an important aspect which students need to develop through this activity. They could follow the instruction and easily recognize the next pattern. Based on their observation, the children challenge their peer to identify the pattern through the variations in the rhythm and sound. Over to Thakur ma'am.
Yes. Now coding, second activity is the coding. So coding are used to transmit the secret messages. Codes are nothing but patterns taken to the next level. It is a real life application of the pattern recognition and abstraction. So the children of age group 9 to 12 years are very curious about the coding. They are very interested. So to nurture their interest, we ask the student of standard 4 to create their own code after giving certain basic instructions. For example, if I have written there A to Z letters, 26 letters are there, and we are assigned some messages, some numbers are there. So they have to identify the pattern recognition, like A is assigned 1, B is assigned 3, C is assigned 5, and likewise the numbers has been allotted. Then they were somewhere are saying that these are the odd number series. Some are saying that every time we are adding 2 in each number, so we are getting the next number. Then they correlated the number and the alphabets both. So impact of the activities are the students have learned more concepts of coding using the patterns. Then basis of this estimation in the subject is the pattern recognition. So face the challenges. Some students were excited to learn something new, or very some difficulties to understand the concept of coding, and some students to perform the activity because of the area of the interest. So I overcome the challenge to make them familiar with the comfortable and use this sequence. As they got comfortable, we ease down the solution in the parts or in the chunks. So in this way, the students make their own code, and I will show one video of one of the students who explained her experience on the coding. So when she was explaining and she create her own code, just a minute, I'll explain this coding. Right. The video is not just sorry, the video is not available.
Okay. Even if you share the video with us, it is okay.
1 minute.
Just try, ma'am. Just
Thank you, Jayashree ma'am, and thank Sheetal ma'am. We are running out of time, so let us move to the next presentation.
Okay, ma'am. Fine. It's not. Sorry.
Okay.
Thank you, ma'am.
So thank you very much. So next we have under the theme CT-based unplugged activities in the classroom, a presentation from Ashwini Ukkede ma'am and Rajeshri Saraf ma'am from School of Scholars Kolkhed, Akola. The topic is tools to enhance CT skills. Over to you, ma'am.
Thank you, ma'am. Once again, very good afternoon to all of you. Topic for the paper presentation is tools to enhance CT skills. Since we have integrated computational thinking curriculum with mathematics curriculum from 2017-18, and while conducting CT modules in class and practicing all different modules across all the classes, we have realized that we should plan and integrate other activities which are aligned with the CT skills. So we have thought of integrating different activities in our mathematics curriculum across all the grades from standard 3 to standard 12. So here I'll be sharing few of the activities which are integrated in curriculum which are aligned with the CT skills. So first activity was conducted and implemented for standard 3 to 7. That was 10-gram activity. So as you all know that solving 10-gram puzzle requires proper algorithm, systematic approach of solving the puzzle. So this activity was conducted for class 3rd to 7th. Every month we are given one problem figure to the students, and then students were asked to find the solution for each of the puzzle given to them monthly, and students have presented the solutions on their own in the mathematics class. So basically the activity started by making students to have a set of all 7 pieces of 10-gram. And then teacher have demonstrated how to use those 7 pieces to solve the problem figure. So while doing so, teacher have observed that students are facing difficulty in using all the 7-10 pieces at a time to solve the problem figure. So what was done? Students were instructed to use only 5 basic 10-gram pieces to make the basic geometrical figures. Instead of directly switching to solving the problem figure, we have tried using only 5-10 pieces and making the basic geometrical shapes. So students have tried all possible combinations of 5-10 pieces to form the square, triangle, rectangle, and parallelogram. And they have made these geometrical shapes, different geometrical shapes using all 7 pieces in the next level. And for the next level, a puzzle of making objects, animals, and alphabets using 7 10-gram pieces was conducted. I would like to share how students have used the 5 10-gram pieces for making different geometrical shapes. So as I said, students initially have tried the combination or making square using 5-10 pieces. So 5-10 pieces are placed in a different way by different groups. They have made the square, and the big triangular pieces are later on arranged and kept along this along the side of the square so as to obtain the trapezium, parallelogram, rectangle, and other geometrical shapes. One of the group has tried making square by starting with a small square piece, then placing a right angle triangle, arranging the remaining small 10 pieces so as to get the square. Some of the group have tried the same basic formation of a square with different ways. One of the problem figure given to student was making an isosceles triangle. Now by this time students were aware that to make any geometrical shape, the basic requirement is to form the square using 5-10 pieces, and the remaining 2 big triangular pieces can be arranged so as to get the solve the problem figure. So for solving this problem figure, again the student have used their already constructed knowledge of making the square and placing the remaining 2 triangles along the squares to form the isosceles triangle, and in this way they have solved the problem figure, and in the next level they have solved the different and complex figure also. Second activity conducted was a treasure hunt activity. Before this, I would like to mention here that students have got the core idea of dismantling and arranging these 5-10 pieces along with the remaining 2 triangular pieces so as to form the different triangular shapes and 10-gram pieces, and for solving the different 10-gram puzzles. Second activity conducted here was a treasure hunt activity for standard 8. Here, clue cards were prepared by the student teachers, including the question based on CT skills like decomposition, abstraction. These clue cards were placed at different places in the school campus. The class of 40 students was divided into group of 5. First clue card was given to all 5 group in a class itself. By finding the solution to the first question, students have completed the treasure hunt activity. The answer of the first question was the clue for the second question, and likewise the treasure hunt activity was conducted. So students have solved a total 5 clue card using systematic search, counting combination, pattern recognition, and other CT skills. Here are a few examples of the clue cards or the question given as a clue card. One of the question was, which number is the odd one out from the given one? So here systematic search was used by the student by observing the unit place digit number, or what is the pattern? Is there any pattern in the numbers given in the sequence? So such kind of CT skills are used by student. Another question was identify the odd one out and move to the room number formed by the answer for this question. So here counting combination skill was used. Then another question was, this picture was given. To open this safe, you have to replace the question mark with the correct figure. So find the figure by determining the pattern behind the number shown on the safe. So pattern recognition was used. In this way, students have completed this activity. You can see the glimpses where students are enjoying along with the teacher to complete this treasure hunt activity and find the treasure. Then third activity implemented here was Bebra's challenge questionnaire. Since every year our school is appearing for this challenge, we have prepared our student by providing the questionnaire, weekly questionnaire to all the students. We have selected the questions for this from the Bebra's booklet, and the selection process for the question was like first from the respective group, like for 6 to 8 Bhaskara group was there. So the question for standard 6, 7th, 8th are selected from Bhaskara group, that is 2 of level A. Accordingly, for level B and level C, the questions are selected. For these questions, the Google Forms are prepared and it was shared by the teacher in Google Classroom. Students have solved it and shared the solution. Most importantly, how they have shared, the way of finding the solution was shared by the student in the classroom. So such kind of questions are given in form of questionnaire, weekly question, and students have explained the solutions by their own. Now, what was the impact of all these different activities which has helped us to enhance the CT skills? So it has not only created the interest among students, but it has also created interest among parents. So here you can see parents have also showing the active participation in the activities conducted by schools on both Saturdays and PTM. Also, students have shown different ways of solving the Bebra's questions and CS modules in a very different way. So that has been shared here in the video. If it will play, it will be great. So here students are showing the variation in solving the binary operation puzzle.
And we can't see the video. And I think it is okay if you just share the video with us. Ma'am, we can't see the video. And it is okay if you just share the video with us and we move ahead.
Okay, ma'am. Okay. So through this activity, we were able to create the interest among students and among parents, and they have now showing the active participation and interest in solving different questions and presenting the modules in the PTMs and at other school activities also. So that's all from my side. Thank you, ma'am. Thank you for giving me the opportunity.
Yeah, thank you, Ashwini ma'am. It was a wonderful presentation. And now it's time for the closing remark. So I call upon Sonia Gacha ma'am for the closing remark.
Good afternoon, everybody. Am I audible?
Yes, ma'am.
Yeah. Give us a second. You leave me. Yeah, thank you. Okay, so first and foremost, I thank everybody for all the effort all of you put in. It was not just about writing the abstract, the whole process of what I liked was that independently you were able to create your presentations, right? You were able to highlight the ideas that you thought were important, because these were not mentored presentations. And what the principal sir rightly said, that, you know, the tree in Meghe is now growing, right? And it is not just about growing in size, like you're strengthening it by, you know, reinforcing the concepts. We have moved from when we started way back in 2017-18, there were like a few teachers who were involved, right? We did math and science, and then slowly you guys moved ahead. And what I like is, if you see, till last year our abstracts were very restricted to just the CT activities that you were taking in the classroom, right? But now today's presentations, you could see that you have seen how those CT activities could be taken beyond the curriculum, right? It was not restricted just to saying, oh, we did Sudoku and these, you know, so many children. If you remember, like till last year, even now when you do counting combinations, right? Even though the lesson plan was discussed, what I liked was you were moving from abstraction to concrete objects. So these are just some of the points I would like to highlight. And of course, learning with fun, right? If you see all the slides, you know, some of you have added pictures of the children doing the activities, and we can tell even from your expressions that, you know, it is all about learning with fun. And one more important point that I would like to share here is that when we shared the template, right, we had said it was the activity, the challenges, and the impact. So what I particularly liked was that you have identified topics that children find difficult, right? And then you have used computational thinking to simplify the concept so that they are able to do it, whether they were examples in science, whether they were example in math, like one of the teachers took polynomials, somebody took hydrocarbons. So what all this leads to is expanding the scope of CT. And another important point that all of you made was, in your presentations, I noticed is students are being able to apply the CT skills, right? Abhi tak kya hota tha? We used to say teachers are applying the CT skills to teach a concept. So I feel that is a big shift. And of course, it was very, very encouraging and very motivating for all of us at CSPathshala to see the kind of effort that all of you are putting in. And I would also like to take this opportunity to thank everybody at Meghe schools, you know, Abba Meghe, Ajinkya, Geeta, Sabita, Pratiksha, you know, all the HODs, the principals who have, you know, constantly motivated all of you. See, this journey has not been easy. Let's put it like that. But all of you have taken these small steps and we have really grown. So thank you so much for all your support.
Thanks, Sonia. This is, let me see. Yeah. This is Vineet and Sarang from ACM Nagpur chapter. So first of all, like I completely resonate with what Sonia said. I have been seeing a couple of presentations in the last few years on CTiS when the conference was held here at Nagpur and this regional conference, and there was one more regional conference earlier that happened basically. So overall, I would say like the maturity level of applying CT concept, using CT concept is increasing over a period of time, right? So it started with very initial thing. Now seeing that those concepts are applied to solve even more complex problems related to chemicals or those kind of stuff is really good and encouraging to see, right, how teachers are innovating themselves and taking it ahead. So one thing I would suggest would be helpful is like whatever is the best coming out of this thing, that gets fed back into the loop and that becomes more of a practice to apply this to teach students across different levels. That could be a best thing that we can do as an outcome of this conference as well. Right, so that are my quick thoughts on this one. First, again, thanks to all the teachers who made efforts for presenting in this conference, preparing presentations, and also the communication and the whole thing was really absolutely perfect to execute this thing. Thank you very much on this one. Would also like Sarang to say a few words on this.
Yes, we would like to thank organizers, School of Scholar. Also like and
yeah, thank you very much.
Thank you very much.
Yeah, thank you so much. Thank you everybody for giving your time. And I think each one of you were really wonderful and tried your best to present your thoughts. And I'm sure that we'll have selected presentations for the Pune conference. Looking forward to take this moment ahead and reaching to more and more teachers with the support of the complete CSPathshala team, my team, and ACM team. Thank you so much. Thank you so much for joining. And we stop here.
Thank you, ma'am.
Thank you so much.
Thank you so much. Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.